Okay, so let's start. Okay, so let's discuss yung last pre-board natin is or last March 4 and 5, 2020. Okay, so naman tayo ngayon. Okay, so sige, no? So let's try. Let's start. Okay, so problem number 1, lumabas noong September 2022. A single phase 100 kVA 1000/100 volts 50 Hz transformer has a voltage drop of 5%. Okay, so pag sinabi natin voltage drop, yan. Okay, our percent voltage drop is actually equal to our percent impedance. Okay, so binanggit din dito, sabi, of this, 3% are due to resistance, is due to resistance. Therefore, okay, so kung 5% drop, and the percent drop due to resistance is 3%, ang sabi sa problem, the percent regulation of the transformer at full load with 0.8 lagging power factor is blank. Okay? So, depende. No? So, kung kumukuha tayo ng voltage regulation, laging nakadepende yung formula natin, okay, dun sa mga parameters na binigyan. Okay? Since binigyan tayo dito ng mga percent impedance and resistance, ito yung formula ang gagamitin namin. Okay? The percent voltage regulation is just equals to percent resistance R cosine theta plus or minus percent reactance sine theta. Okay, so take note, gagamit tayo ng plus kapag lagging yung power factor and minus naman kapag leading. Okay, so based dito sa direct formula natin, okay, so meron na tayong percent resistance, ang nawawala na lang percent reactance. Okay, so dito, no, so based sa ating impedance triangle, okay, our percent resistance, reactance, sorry, percent reactance X is just equal to the square root, okay, of percent impedance square minus percent resistance square, which is just equals to 5 square or square root of 5 square minus R square. Okay, so percent reactance therefore is 4%. Okay, so since meron na lahat yan, no, so direct formula lang, okay, our percent voltage regulation is just equals to, of course, no, since percent resistance na yung gagamitin, okay, percent voltage regulation na agad yung lalabas. Okay, so 3 cosine. Okay, so hanapin muna natin yung theta. Okay, so power factor, ito na lang sa gilid, no, is just equals to 0.8 or cosine power factor angle. Cosine theta is equals to 0.8, yun yung power factor natin. Okay, therefore, theta is just our cosine ng 0.8. Okay, which is just equals to 36.87 degree. Okay, so 36.87 degree, no? So yun yung gagamitin nating angle. Okay, so 3 percent resistance times cosine theta, okay, which is actually yung power factor, no? So for cosine 36.87 plus, no, since lagging, so plus yung gagamitin natin. Okay, so percent resistance is 4 sine theta. Okay, so sa theta is 36.8. Okay, so ang lalabas ditong sagot is equals to, okay, so 4.8%. Okay, so letter A. Okay, tatandaan, no? Okay, question dito. Okay, so tuloy lang namin. Next. Next question, lumabas ng September 2022. Which of the following plant has the highest capital cost? Okay, so between this plant, no, so kung mapapansin natin, okay, si nuclear power plant yung may pinakamataas. Okay, bukod kasi sa kailangan pa niya ng malalim na study, no, bago tayo makapagtayo ng nuclear power plant. Okay, in terms of facilities and materials naman, okay, mga hybrid or okay, sobrang mamahal ng mga materials. No? Okay, so tamang sagot, nuclear power plant. Okay, so letter. Okay, diesel power plant, sir, bibili ka lang naman yan. No? Okay, so magkakaroon ka na ng diesel or generator na ganyan. Okay, thermal, no, so kailangan din ng plant, hydro. Okay, pero ang tamang sagot, nuclear power plant. Siya pa rin may pinakamataas na capital cost. Okay? Next. Question number 3, no? So lumabas ng September 2022. Differential relays are used to protect the equipment against A. So letter A, no? So internal faults. Okay? So yun yung use ng differential relays. Okay? Next. Next question, lumabas nung September 2022 pa din. Okay, so 1 to 25 natin yan, lumabas ng actual ng September 2022. A step-down transformer is used to blank. Okay? So a step-down transformer, mathematically, no? So pwede rin natin siyang express. Okay? A transformer ratio, NP all over NS. Kapag mas malaki yung number of turns ng primary sa secondary, okay, step-down transformer. Okay, but our turns ratio, primary all over sa secondary, is just equals to the voltage primary all over the secondary. Okay, ibig sabihin ganun din. Okay, the voltage primary of a step-down transformer is greater than our secondary. Therefore, okay, so a step-down transformer is used to decrease voltage. Okay, first, no, step down, no, stepping down voltage yung meaning. Decrease in voltage. Okay, so letter B. Okay, so yun yung problem number na ba to? Okay, problem number 4. Okay, next. Question number 5. Okay, so lumabas ng May 2010, bumalik ng September 2022. Okay, so in design of electrical power system, the IEE or ANSI device number natin, okay, so 1 to 100 yun actually. Okay, of course, no, kung gusto nyo kabisaduhin yung IEE device number, lumalabas sa board exam yan, pwede naman. Or, since medyo madami, no, so kayo nang bahala dyan. Okay, so pwede nyo rin kabisaduhin yung mga lumabas na ng actual board. Okay, so for this question, okay, so question number 5, okay, so which of the following is device number for AC circuit breaker? No? AC circuit breaker is actually number, number 52, no? AC circuit breaker. Okay, so ano lang, no? So quick lang, no? So 50 is actually an instantaneous overcurrent relay. Okay. Si 60 naman sir, si voltage or current balance relay. And si 72, no? So di ko lang sure, no? Pero parang lumabas na rin tong 72 na to. Okay, si DC circuit breaker naman to. Okay? So yan. So syempre tamang sagot pa rin, 52, no? AC circuit breaker. Okay, ANSI device number, no? Okay, yun yung problem number 5 natin. Okay? Next. Okay, next question. Okay, so lumabas ng September 2022. Two wires are made from the same material, have the same lengths but different in diameters. Okay, they are connected in parallel to the battery. The quantity that is not the same for the wire is blank. Okay, so sinabi, no, wire daw is connected in parallel. Okay, so kapag parallel, sir, no, so regardless kung anong component na connect natin, no, so same yung, regardless tuloy. Regardless, no, so pagka kasi parallel, no, same yung potential difference niya. Okay, while yung current naman natin is different between nodes, no? Kung especially kapag magkakaiba yung resistance. Dito kasi sinabi same lengths but different in diameters, therefore different din yung resistance. Okay, kaya dito ang sagot, the quantity that is not the same for the wire is of course yung current natin. Okay, current, so letter. Okay, yung letter A hindi yan, no? Kasi since parallel, equal yan. Okay, so problem number 6, letter B, current. Okay, so magkakaiba yung kuryente, no? Pag magkakaiba yung resistance across each branch ng ating parallel circuit. Okay, so letter B. Next. Okay, next question. Two solid spheres have the charge of 1 coulomb and negative 8 coulomb. Okay, the permittivity of free space is 8.85, so etc. The distance between the sphere center is R, which is 0.3. Determine the force on the spheres. Okay, so for this particular problem, okay, so lumabas ng September 2022, I mean, okay, Coulomb's law lang. Okay, Coulomb's law, so the force between sphere is just given by this equation, Q1 multiplied by Q2, all over 4 pi, okay, epsilon sub 0 or epsilon naught, okay, epsilon sub R T squared. Okay, so take note, ano ba yung unit ng ating force? Okay, naka-Newton siya. Therefore, yung system natin dito is MKS system. Okay, since naka-Newton yan. Okay, therefore, dapat yung Q natin is in column. Okay, yung epsilon sub 0 natin, ito naman yun, no? Naka MKS din siya, no? Meter kilogram system, okay, which is 8.85 times 10 raised to negative 12. Okay, and yung epsilon sub r, okay, since walang binanggit, okay, so may binanggit ba kung anong material? Okay, since walang binanggit na material, no, o yung dielectric na ginamit, i-assume natin na air yun. Okay, where the relative permittivity is equals to 1. Okay, then distance should be in meter. Okay, kapag nasunod yung convention na yan, okay, yung force natin would be automatically in Newton. Okay, so force F is just equals to Q1. Sir, dapat in column, so in column naman, no? So 1 column. Okay, so huwag na natin lagyan ng unit, no? Nandun na yun sa kabila. So 1 column multiplied by negative 8 column all over 4 pi, okay? So multiplied by 8.85 times 10 raised to negative 12. And distance, sir, yung distance natin dapat naka-meter. So naka-meter naman siya, no? So 0.3 squared. Kapag kinumpute natin to, okay, our force F is just equal to, okay, so lalabas na sagot, negative 8, approximately negative 8 times 10 raised to 11 Newton. Okay, so letter B. So yan lang yung problem number 7 natin. So madali lang. Column slow lang yung pinansin. Okay, question. Okay, so next question, sabi, so lumabas noong April 2011, bumalik ng September 2020. Okay, there are 4 nodes A, B, C, D, and there are 6 branches connecting each pair. Okay, if IAB 16, ICD 23, and IDA is 39 ampere, find IBs. Okay, so dito, no, so drawing muna natin. Okay, meron daw tayong 4. Okay, laki-laki ako lang yung drawing ng content. Okay, A, B, C. Okay, which is connected, okay, by 6 branch. Okay, kung mapapansin nyo, dito sa square na to, or dito sa orientation natin, 4 branch pa lang yung ginamit. Therefore, yung ikaliwa tsaka ika-6 yung diagonals natin. Okay, so 5. So 1, 2, 3, 4, 5, and 6. Okay, so dito sabi, if IAB is 16 ampere, so IAB, no, so from A to B is 16 ampere. IAB. Okay, and ICD, sir, ito yun, is 23 ampere. Okay, and IDA, okay, IDA is 39 ampere. Ito, no? Okay, 5 IBs. Okay, so mapapansin nyo dito, no? So yung IBC natin, or para makuha natin yung current, no, nung kada branch natin, kailangan at least dalawa yung alam nating current. Kasi nga, for example, no, for this particular node, alam ko yung ICD, sir, pero di ko alam yung current dun sa dalawa. Therefore, dalawa yung unknown ko. Hindi ko siya masasolve using KCL. Okay, so dito kasi yung problem na to, no, so is actually a troubleshoot problem. Okay, yung IBC na yan, ang pinapahanap talaga is actually, so troubleshoot to, no, IAC. Okay, yun yung pinapahanap talaga dito. Okay, so kung mapapansin nyo rin kasi, no, with respect to dun sa drawing natin or dun sa representation natin, dito sa particular node na to, tawagin ko na lang X. Okay, meron tayong current flow dito. Okay, so at X, okay, all current entering the node must equal to all current leaving. Okay, so ano ba yung mga entering currents natin? Si IDA, papasok siya doon, no? Okay, so meron pa ba? Okay, wala. Okay, so in terms of IAC naman, no? IAC, ito naman yung ating current. Okay, so palabas siya ng node or going away siya from the node. Okay, so all currents entering must be equal to all current leaving the junction, which is IAC, okay, plus IAB. Kaya yung IAC ko is just equals to IDA minus IAB. But my IDA is 39, my IAB is 16 ampere. Kaya ang magiging sagot natin dito is 23 ampere. Okay, so letter. Okay, so titingnan din natin, no? So yun yung tamang sagot kasi nga troubleshoot yung problem. Kung titingnan natin yung IBC value natin. Okay, so IBC, so sabihin ko na lang ganito siya, no? Okay, kung mapapansin nyo, kung ang AC na na-compute ko is 23 ampere, Okay, for this particular node, lahat ng current entering, which is the IAC and IBC, should be equals to the current leaving, which is ICD. Eh sir, ano ba yung IAC ko? 23 plus IBC is just equals to 23 ampere, yung ICD natin. Kaya yung IBC natin dito is actually equal to 0. Okay, which is wala sa choices. Kasi nga, troubleshoot siya, no? So, hindi naman talaga si IBC yung pinapahanap. Okay? Pinapahanap talaga dito is si IAC. Okay? So, tamang sagot, 23 ampere. Okay? So, kung kaya nyo nang tandaan yung troubleshoot tsaka yung drawing, okay? So, pag lumabas lang to, so kung makikita nyo ulit to, tatandaan nyo lang 23 ampere. Of course, madali lang naman yung KCL, no? Kaya wala magiging problema as long as na alam nyo yung drawing. Okay? So, yan yung sagot natin for problem number 8. Okay? So, problem number 9. Okay, problem number 9, okay, September 2022 lumabas. Okay, actually nasa handouts din ng DC circuits to, no? So ito yung prerequisites in connecting, okay, compound generator. Sabi, pag compound yung generator natin, okay, so compound generator, so ito yung itsura, no? Okay, actually yung huli nating sinulog doon last time na problem sa DC gen, okay, compound. Okay, sabihin ko na lang meron tayong compound generator A, okay, and meron din tayong B. Okay. Supplying a common load. So, kung ano man yung load na susuplayan nila, no? So, dito yun. Okay, so then i-connect. Okay, so mapapansin nyo, nagre-require ng equalizer connection si compound generator to maintain yung balance ng voltage across our field, no? Yung series field dito. Okay, kasi kapag naglagay tayo ng equalizer connection yan, ayan, ina lang. Okay, so same voltage na sila kasi connected sila in parallel. Okay, kaya pag lumabas ng board exam to, okay, ang tamang sagot dito, it is actually a prerequisite in connecting compound generator in parallel. Kailangan may equalizer connection. Okay, so letter A. Okay, so tatandaan mo yun. Okay, si shot generators hindi na kailangan, ano? So hindi na no need na siyang lagyan ng equalizer connection. Okay, so ano lang, no? Si in general pag lumabas sa board exam, si compound generator yung isasagot mo. Okay, so tamang sagot letter A. Okay, question dito. Okay, so next, problem number 10. Okay, problem number 10, so lumabas ng September 2017, okay, bumalik ng September 2022. What is the maximum output power of a cellular transmitter? Sir, no, cellular transmitter, okay, so letter C, no? So 3 watts. Okay, so na-discuss na rin yan sa lecture nyo, no? Okay, so letter C. Of course, walang computation na, no? Constant lang yan. Kinakabisado lang yung value. Okay, so 3 watts. Okay, next. Okay, next problem, problem 11. Okay, so lumabas noong September 2022. Okay, so each cell site contains blank. Okay, so each cell site must contain, okay, so letter A, so repeat. Okay, so repeater, no, so main function lang naman yan is to, of course, no, one main function is to amplify weak signal and also to propagate yung signal niya. No? So, kailangan merong repeater yung cell site natin, no, para makarating yung signal to the receiving. Okay, so tamang sagot is letter A. Okay, next. Next question is, lumabas noong September 2015, September 2016, and September 2020. Okay? So ito yung given. So hindi ko na siya babasahin, masyadong mahaba. Okay? So for a particular three-phase transposed line, okay, ito yung mga given. So ano ba pinapahanap dito? Capacitance per phase for a 20 kilometer of line in microfarad. Okay? So for a three-phase line, okay, sulat ko muna yung formula na gagamitin natin. Okay, for a three-phase line, okay, the capacitance per phase is can be solved using this formula. Capacitance per phase is 17.7. Okay, so times 10 raised to negative 12 all over Ln, okay, nung ating D equivalent all over our radius. Okay? Ang measurement natin dito, or unit natin is in farad per meter. Okay? So kung gusto natin makuha yung total capacitance ng linya natin, i-multiply lang natin sa per unit length o sa unit length natin. Okay? Which is 20 km. Ang matitirang unit is in farad. Okay? So dito, sige, no? So dito hanapin muna natin yung ating D equivalent. D equivalent is actually my GM. Okay, formula natin dito, sir, it is actually the square root o n root, I mean. Okay, nung distance combination natin dito. So, meron tayong three-phase transposed line. Ito yung tatlong linya natin. So, 1, 2, 3. 1, 2, 3. Okay, so 1, 2, 3. Distance ng 1 to 2, sabi, 7. Distance ng 2 to 3, 7. And distance ng 1 to 3, 14. Okay? 7, 7, 14. Okay? Therefore, yung ating D equivalent is just equals to, okay, so D1, 2, D2, D2, 3, D1, 3. Okay? It is just equals to the cube root. Okay? Of 7 times 7 times 14. Ito yun na, 7 feet, 7 and 4. Okay? So, pag kinumpute natin to, okay, ang lalabas na value sa atin, okay, so 8 point something to. So, calculate ko lang ulit. Okay? So, 40. Okay, so, lalabas is 8.82. Okay, feet. Okay? So, dito, so meron na tayong D equivalent. Okay, hanapin na lang natin yung R. Okay, R is actually the radius ng conductor. Okay? So, yung GMR dito, actually, ang gagamitin natin ito kapag kinukuha yung inductance. Pero sa capacitance per phase, di natin ginagamit yung GMR. Okay? So, so tatandaan natin, okay, kapag may binigay na problem or may binigay na transmission line, titingnan natin kung nakabundle siya. Okay, kapag nakabundle yung ating conductor, ibig sabihin may magkakasama, no? O parang ganito siya, no? So, kailangan natin kunin yung effective radius, no? Okay, sir, paano mo malalaman kung nakabundle? Okay, based dito sa parameter na binigay. Okay, sabi dito, 2 ACSR conductor, which is actually meaning 2 bundles. Okay, so ngayon, kung nakabundle yung conductor natin, our R should be the effective, okay, bundle radius natin. Okay, kapag 2 bundles yung conductor, ito yung direct formula natin. For a 2 bundle conductor, the effective radius is just equals to the radius ng conductor times the distance between conductors. Okay, so distance between the bundle conductors. No? So R times, of course, magkakaiba-iba yan. No? Kung kapag 3 bundles, 4 bundles, etc. Okay, pero pag 2 bundles, no, parang ano lang siya, geometric mean lang siya. No? Square root ng radius ng conductor times the distance ng bundle. Okay, so dito yung D equivalent natin in feet. Okay, make sure lang natin na sa formula, pag in-input natin siya, magka-cancel to. Okay, kaya kung D equivalent mo is feet, dapat yung radius ng effective radius ng bundle nyo, naka-fit din. Okay, okay, tuloy lang natin. Okay, so sulat ko lang yung direct formula dito. Ayan, nilagay ko na lahat ng mga given. Okay, so the direct formula, capacitance per phase, 17.7. Okay, 17.7 pi, I mean. Times 10 raised to negative 12. Ln ng D equivalent all over the radius ng bundle. Okay, in farad per meter. Okay, sir, meron na tayong D equivalent. Na-compute na natin niya kanina. 8.82 feet. Okay, so para makuha natin yung radius ng bundle, it's just equals to the square root of the radius ng ating conductor and the distance ng bundle niya. Okay? So dito, sir, mayroon binigay na diameter. Diameter daw ng ating conductor is 0.741. Okay? Pag dinivide ko ng 2 yan, sir, magiging radius. Okay? Therefore, our radius is just equals to, okay, so 0.3705 inches. Okay, but take note, no? So kailangan kasi naka-fit, no? So para magka-cancel siya dito sa equation natin or dito sa expression natin. Okay, so convert lang natin into feet. Okay, so 12 inch per 1 foot. Therefore, the radius in feet, okay, so divide ko lang ng 12. Okay, so 0.030875. Okay, so check, meron na tayong radius. Distance ng bundle, okay? The distance of our bundle, B, is just equals to 6 inches. Okay, so kailangan naka-fit pa din. Okay, so 12 inches per 1 foot. Okay, therefore, the distance ng bundle, 0.5 foot. Okay, so meron na tayong effective radius. Okay, So sige, no? So lagay na natin dito or substitute na natin. The capacitance per phase is just equals to 17.7 pi times 10 raised to negative 12 ln ng ating D equivalent. Okay, so 8.82 feet all over the radius ng bundle. But the radius of bundle, ito yung formula. Okay, square root ng radius ng conductor, okay, which is 0.0875. 0.03 0875 times 0.5. Okay, so naka-fit square yan. Okay, ang lalabas na unit niyan, sir, is in farad per meter. Capacitance per phase, therefore, in farad per meter is, okay, solving ko lang. Negative 12 all over ln ng 8.82. Okay, so ang lumabas? Okay, so 1.305 times 10 raised to negative 11 farad per meter. Okay, so para makuha natin yung capacitance ng line, okay, for a 35, tama ba? 35 kilometer ba? 20 kilometers, so ano pala? For a 20 kilometer line, okay, so the capacitance per phase, which is 1.305, okay, so times 10 raised to negative 11 farad per meter, but at 20 kilometer is just equals to 20,000 meters. Okay, so multiply mo lang sa total length, which is 20,000 meters. So cancel yung meter. Therefore, the total capacitance per phase natin, okay, for a 20 kilometer line is, okay, so pagka kinonvert no in microfarad, lalabas 0.2609, okay, so microfarad. Okay, kaya tamang sagot natin is letter. Okay, so letter. Okay, so question dito. Okay, so tuloy lang natin. Okay, so next. Okay, next question. So lumabas ng September 2022. A parallel RL circuit draws a total current of 17 amps. Okay, so drawing na lang din natin. RL. Okay, draws a total current, yung magnitude, no? Which is 17 ampere. Okay, so the total power ng circuit is 1.8 kilowatt from a 120 volts AC supply. Okay, find the value of L. Okay, so dito, so maraming way, no, para masolve to. Okay, so pwedeng dumaan muna kayo ng impedance triangle, and since parallel siya, pwede rin naman yung admittance triangle natin. Pero ang pinaka-easy dito, pinaka-easiest way natin to solve this is using power triangle. Okay? So may power triangle tayo, no? So real power P, Q, and S. Okay? So based dito sa problem na to, okay? So isa lang naman, sir, yung panggagalingan ng ating real power, which is actually the resistor, and isa lang din yung panggagalingan ng reactive power natin. Kasi isa lang din yung reactive component natin, no? Si L lang or si inductor lang. Okay? So si L may certain value ng XL. Okay, sige, no? So solvein muna natin si S. Our S magnitude, no, pag single phase is just the current magnitude o total current multiplied by the total voltage. Okay, so current natin, sir, binigay 17. Okay, yung voltage natin, sir, o yung source natin, source voltage is 120. Okay, so ang lalabas dito, so 17 times 120 is just equals to 2040 volt ampere. Okay, so since gagamitin natin ang way, no, para makuha natin yung L is kunin muna natin yung Q, then doon natin hahanapin yung value ng XL. Okay? So kunin muna natin si Q. Our Q based dito sa ating right triangle, yung power triangle natin, is just equals to S square minus P square. Therefore, our Q is just the square root, okay, of S square, which is 2040, minus, or square minus, yung real power natin, which is 1.8 kilowatts or 1,800 watts. Okay, so ito ay 1,800 watts. Okay, therefore, Q is just equals to 960 volt ampere reactive. Okay, but take note, our Q, which is the reactive power, isa lang panggagalingan yan lang, yung ating reactive component L. Okay, so pagka sinulat natin yung formula ng Q, Q is just equals to, okay, since connected sila in parallel, the total voltage 120, yung source voltage natin, equal lang per branch ng ating parallel circuit. Okay, so V square all over XL. Okay, so parang V square all over R lang, no? So where XL is yung load natin. Okay, so therefore our XL is just equals to V square all over Q. But my V is 120 square all over RQ, which is 960. Kaya ang lalabas na XL dito is 15 ohm. Okay, but take note, L yung hinahanap. So XL is just equals to 2 pi FL. And L therefore is 2 pi, XL all over 2 pi F. Okay, sir, meron na akong XL. Ang XL ko is 15. Wala pa ako ng frequency. Okay, since wala tayong way, no, para ma-solve yung frequency dito, okay, mag-assume lang tayo ng frequency. No? So, assume. Of course, nasa Pilipinas naman tayo. No? So, best assumption natin, yung frequency natin is 60 Hz. Okay, so pag hindi lumabas ng 60, no, try yung 50. Pero lalabas yun dito. Okay, so our XL is 15 divided by 2 pi times 60. Okay, so ang lalabas na sagot dito, pag kinalculator natin, is letter A. No? So 0.0389. 398 MB. Okay, so mapapansin nyo, no? So dun sa choices natin, okay, so ang available lang ng choices natin is the letter A. No? So yung pinakamalapit, 0.0389. Okay, so medyo troubled lang or medyo mali yung pagkakalagay ng tamang sagot. Okay, syempre, pipiliin natin lagi yung pinakamalapit tsaka yung pinakakamukha. So, letter A yun. Okay, pero pag lumabas sa actual board exam yung tamang sagot na to, yung 0.0398, syempre yun yung pipiliin. Okay, so letter A. Okay, so yun yung problem number 14 natin. Okay, so next, problem number 13 pala to. Problem number 14. Okay, problem number 14, ilabas ng September 2022. 420 ohm resistor are connected in series and the combination is connected in 20 volt EMF device. The current in one of the resistor is blank. Okay, so take note, since connected sila in series, okay, source. Okay, so apat na resistor. Okay, so since connected sila in series, okay, yung current total o total current natin is just equals to the individual current per resistance na resistor natin. Okay, sir, hanapin muna natin yung total current. Our total current is just equals to the total voltage all over the total resistance. Okay, total resistance are total. Since connected sila in series is just the sum ng individual resistance. Sir, pare-parehas lang yung value na, no? So, 4 parang 4 times 40 lang din. Or 40 plus 40 hanggang masam mo yung apat. 4 times 20, I mean. Which is 80 ohm. Okay, the total current is the total voltage all over the total resistance, 80, which is 0.25 ampere. Okay, but take note, no, since series sila, yung total current natin is equal lang dun sa individual current per resistor natin, no? So I1, I2 until I. Okay, kaya tamang sagot dito, letter A, no? So 0.25 ampere. Ayan yung problem number 14 natin. Okay? So next. Okay? So lumabas noong September 2021. Bumalik ng April 2022 then, okay, bumalik ng September 2022, no? So magkakasunod na board exam siyang lumabas. Okay? So Faraday's law states that the induced voltage is proportional to blank. Okay? So under Faraday's law, the EMF induced is just equals to, okay, So, flux, no? So, negative N or number of turns flux per unit. Okay, yung negative dito, yung less law na tinatawag, no? Yung nagkukos ng EMF is laging opposite yung direction. So, lens law. Okay, so dito, so kung mapapansin nyo sa formula, our EMF induced is actually proportional, okay, to the rate of magnetic flux. So rate of, ito magnetic flux per unit time. Magnetic flux per unit time is actually the rate of magnetic flux. Okay, so letters. Okay, so yun yung tamang sagot natin. Letter C. Okay, rate of magnetic flux. Okay, so next. Okay, next question. Lumabas noong April 2022, bumalik ng September 2022. Okay, so at time equals to 0, okay, the charge on the 50 microfarad capacitor in LC circuit is 15 microcoulomb. And there is no current. If the inductance is 20 millihenry, the maximum current is blank. Okay, so under LC circuit, LC circuit is famously known as the flywheel circuit, no? Yung kung saan yung energy stored nila, no, under ideal condition, nagpapalit-palit na. Okay, so LC circuit, okay, they can both store energy, no? So, at a certain time, yung energy stored ng ating inductor, no? Lilipat sa capacitor and pabalik. So, paulit-ulit lang siya. Okay, kapag ideal yung LC circuit nyo, no? So, parang infinitely, no? So, magpapalit-palit o maglilipatan lang ng energy. Okay, pero syempre, since may resistance in between yan, okay, so kapag practical, eventually namamatay or nauubos yung energy. Okay, pero dito sa problem na to, okay, syempre i-assume natin na ideal yung LC circuit natin. Therefore, okay, so for that particular idea, okay, ibig sabihin sir, lagi no, so yung yung total energy ng ating LC circuit should be always equal or constant, hindi nagbabago. Okay? So paano ba yun sir? No? So by virtue of law of conservation of energy, okay, the net or the sum of the energy stored ng ating inductor plus capacitor should always be a constant. Okay? Energy stored ng inductor plus capacitor should be constant. K. Okay? So ngayon dito, so sinasabi niya, okay, dalawa kasi yung condition, no? So at time is equals to 0, so yung initial value, and at a certain time, sige, hatiin na lang natin, at time is equals to 0, and at a certain time, so hindi naman na binigay, where our current is at maximum. Okay? So regardless with respect to time, okay, so yung ating sum ng energy should be constant. Okay? So kaya ibig sabihin niyan, sir, the sum under the first condition, WL1 plus WC2, okay, yung energy stored ng dalawa, should always be constant or equal sa any sum at any time t. Okay? Eh sir, ano bang formula ng energy stored sa ating inductor? 1/2 Li square. Okay, kay capacitor naman, depende kung ano yung binigay. Okay? Since binigyan tayo dito ng charge and capacitance, okay, formula ng work natin, Q square all over. Okay, ganun din dito. Okay? So sabi dito, at time is equals to 0, ito yun ha. At time is equals to 0, there is no current. Therefore, okay, kung 0 yung current dito, 0 din yung energy stored sa inductor natin at time is equals to 0. Okay? So next, okay, 0 na to, no? Okay? So sabi nga, at a certain time, okay, magkakaroon daw o mama-maximum daw yung current natin sa current flowing natin. Okay? So dito sa ating equation, okay, so para masabi nating maximum yung current, ito yung current natin, no? Okay, dapat syempre maximum yung buong expression ng ating energy stored sa inductor. Eh sir, magma-maximum lang naman yung value na yan kapag yung energy stored nung pangalawa o yung nakikihati sa kanya is 0. Okay, kapag 0 yung yung energy ng ating capacitor, okay, it will give us the maximum o max energy sa ating inductor. Okay, and max energy also corresponds to the max current. Okay, kaya tatandaan, no, pag lumabas sa actual to, okay, pag sinabing max energy o max current, okay, kailangan yung i-assume o kailangan yung i-consider na dapat yung energy stored na kay inductor lahat. Okay? So, yung tatandaan. Okay, so yan. So, nauwi na tayo dito sa equation na to. Okay, parang naging equation na lang siya ng work ng ating capacitor and inductor. Okay? So, sige. So, substitute lang natin yung value. 1/2 Q. Okay, yung original Q natin, which is at time is equals to 0. The initial charge daw on the capacitor is 15 microcoulomb. Okay, so 15 microcoulomb. So 15 times 10 raised to negative 6 squared all over our capacitance, which is 50 microfarad. Which is just equals to 1/2 our inductance, which is 20 millihenry, times our current at that particular instant, which is actually our maximum current. Okay, so cancel lang yung 1/2. Okay, pag sinunod natin to, our current, okay, which is the maximum current, is just equals to 15 milliampere. Okay, so letters. Okay, yun yung question number 16 natin. Okay, so pag maximum current, kailangan yung i-assume na yung capacitance o stored energy sa capacitor natin is 0. Okay, so kung eventually may encounter nyo naman maximum charge dun sa capacitor natin, syempre dapat i-assume na yung energy stored dun sa inductor 0. Okay, so dapat 0 yung isa para masabi natin maximum yung isa. Okay, siya lang kasi yung kukuha o siya lang lahat yung mag-i-store ng energy. Okay, so next question dito, question. Okay, so next question is 17. Okay, so problem number 17. Okay, so lumabas noong September 2022. Okay, according to Fleming's left-hand rule, okay, thumbs always represent the direction of blank. Okay, so drawing na lang natin dito. Okay, this thumb represents yung thumb ba, force ng conductor. Okay, the index finger to represents the direction of the magnetic field. And syempre, no, yung ating middle finger represents the current. Okay? Kaya ang tamang sagot dito, no? So in the left-hand rule, thumb, ito yung thumb natin, okay, represent the direction of force, no, yung force ng conductor. Okay? So letter, yun yung problem number 17. Okay? So force on the conductor. Kaya pagka tinuro nyo sa inyo yung left hand nyo, laging nakaturo yung direction ng current dun sa tao. Okay? So yun yung palatandaan ko dito na. Okay? Force, magnetic field, and current. Okay? So tatandaan nyo. Okay, next. Okay, lumabas noong September 2022. Okay, so three capacitance C1, C2, and C3 are connected in series across a 120 volt supply. Find the voltage across C2. Okay? So dito sa problem natin, okay, so pwede nating solve to using the voltage divider theorem ng capacitor in series circuit or di kaya naman yung constant charge idea ng ating series capacitor circuit. Okay? So dito, so drawing na lang muna natin para mas maintindihan natin. A capacitor that is connected in series. Okay, C1, C2, and C3. Okay, sabi C1, 6 microfarad. C2, Okay, C2 is 72 microfarad. And C3 is 18 microfarad. 70. 7, I mean. 72 na lang. Okay, so C1, C2, and C3. Okay, sabi, find the voltage across capacitor 2, which is P2. Okay, so the voltage across C2, no, so para natin sasalbin yan, okay, so take note for series capacitor, okay, constant dito yung charges. Okay, the total charge QT is just equals to Q1, Q2, kung ilan man yung capacitor in series. Okay, so kaya hanapin muna natin yung QT. Okay, our QT is just equals to the capacitance, okay, total multiplied by the voltage. Sure, meron na tayong voltage total, which is 120 volts. Okay, ito yung total voltage natin, no? O yung source voltage. Okay, hanapin muna natin yung total capacitance. Okay, kapag naka-series yung ating capacitor, 1 all over C2 is just equals to 1 all over C1 plus 1 all over C2 plus 1 all over C2. Okay, the total capacitance therefore is, okay, sige, solving muna natin. So 1 all over 6 1 all over 7, 1 all over 8. Okay, so 2.74. Okay, so microfarad. Total charge, therefore, QT, is just the total capacitance, 2.74 times 10 raised to negative 6, multiplied by the total voltage, 120. Equal to, sir, sa times 120. Okay, so 328.7 microcoulomb. Okay, so ngayon, no, may total charge na tayo. Since series siya connected, okay, equal lang din yan sa charge ng ating first capacitor, second, and third. Sir, ano bang hinahanap? Yung voltage across our second capacitance or capacitance 2. Okay? So, Q is just equals to CV. Therefore, Q2 is just equals to C2 V2. V2, therefore, is Q2 all over C2. Sir, ano ba yung Q2 ko? Q2 ko is equals to the total Q natin, which is 328.7 times 10 raised to negative 6 all over our capacitance 2, which is 7 microfarad. Okay, cancel lang yan. Okay, therefore, the voltage 2 natin, o V sub 2 natin is 46.96 volts. Okay, so letter C. Okay, yan yung problem 80 natin, no? Okay, so next, problem number 19. Okay, so lumabas ng September 2015, bumalik ng September 2020. Okay, so a balanced delta connected load has an impedance Z1 is equals to Z2 and equals to Z3. What is the per phase equivalent in? Okay, so since balance, okay, direct formula, ZY is just equals to Z delta all over 3. Okay, therefore our ZY is just equals to Z delta, but Z delta is either dito sa tatlo kasi balance, no? So Z1 all over 3. Kaya ang tamang sagot, letter E, no? Z1 all over 3. Okay? So yun yung problem number 19. Next. Okay, next problem is problem number 20. Okay, so lumabas ng September 2014, bumalik ng April 2017, bumalik ulit ng September 2020. Okay? The net reactance of an RCL circuit, okay, actually itong RCL na to, no? So arrange lang natin siya, no? It is actually RLC circuit. Okay? Is blank. Okay? Sir, ang net reactance natin is just equals to XL minus XC lang. Okay? So alam na natin yan. Okay? So letter D. Okay? So letter D. Next. Okay? So next question. What is the largest rated room air conditioning unit or air condition unit that may be attached to a 20 ampere branch circuit that also serves another receptacle? Okay, so lumabas noong September 2022. Okay, for this particular problem, okay, so according kay article, no, PEC, article 4.40.7.3 AC. Okay, so sabi niya, the largest air conditioning unit, no? So current, okay, rated current is just equals to ng ating air conditioning unit. Okay, that may be as attached pag sinabi sa problem, no, with or serves another receptacle. Okay, so under the article na yan, mababasa niya rin yan. Serves other receptacles, no, lighting, okay, nakalagay yun sa article na yan. Yung current na i-consider natin, o yung current multiplier natin dito, kalahati lang yung i-consider natin, which is just equals to the full load or the branch circuit current times 50%. Okay, so tatandaan nyo to, no? 50%. Okay, therefore, isa na ba yung branch circuit current natin? 20 times 50%. Okay, kaya lalabas dito, 10 ampere. Okay, so letter E. Okay, so tatandaan nyo, no? Okay, of course, isa sa pinakamadaling subject is PE kapag ka nabasa. Okay, pero pag di nyo nabasa, no, mahirap to. Okay, so hindi kayo basta-basta pwedeng manghula ng multiplier din. Okay, so kahit anong multiplier kasi, no, so yung mga madalas 125, no, 80%, etc. Okay, minsan lumalabas din sa choices, no, kaya ang hirap niyang sagutan kapag di nyo nabasa, of course. Okay, pero pag nabasa nyo, no, so easy na itong mga problem na ganito sa inyo. Okay? So next. Okay, so next question, say lumabas ng September 2017, bumalik ng September 2020. Okay, a 60 Hz short transmission line, so yun yung mga binigay. R is equals to 0.62, L is 93.24 millihenry per phase, to plies a three-phase Y connected load, 100 megawatt, 0.9 lagging, at a power factor, of 0.9 lagging, at 230 kV line to peak. I-determine the voltage regulation. Okay? So since short transmission line lang naman siya, okay, so in terms of voltage voltage regulation, okay, so hindi natin kailangan gumamit ng mga mahihirap o yung mga other methods, no, kapag medium and long transmission. Okay, so pag ganito, no, so ang approach lang natin dito, parang three-phase circuit lang. Okay, so drawing ko lang. Okay, meron tayong sending end, voltage sending end. Ayun. Ito yung voltage sa sending end natin. Siyempre, across dun sa transmission line natin, magkakaroon tayo ng line impedance. Ito si ZL. Okay, then bago siya mapadpad or bago siya makuha ng receiving end natin, which is the receiving end voltage. Okay, so in terms of computation ng voltage regulation, okay, so lagi tayo naka-per phase, no? Regardless kung single phase or three-phase, no? With respect to voltage regulation, kino-convert natin yung problem into its single-phase equivalent circuit. Okay? So dito sinabi, okay, ano ba formula, sir, na gagamitin natin? Okay? The percent voltage regulation formula na gagamitin natin is just, no, the absolute value or the magnitude ng ating sending end voltage minus per phase, no? Minus the receiving end voltage per phase all over the receiving end voltage per phase natin. Magnitude, no? So times 100. Okay, sir. May binigay sa problem. Sabi niya, 230 kV line to line yung ating receiving, no? So nasa ano to, no? So nasa load side yung binanggit na yan. Okay? So since connected tayo in Y, okay, binigyan tayo ng receiving line to line voltage which is 230 kilovolt. Therefore, the per phase value ng ating receiving end voltage is just equals to the line voltage ng ating receiving end divided by the square root of 2. Kasi nga, ulitin ko lang, Y connected yung load natin. Load. Okay, sa 230 kV o times 10 raised to 3 all over square root of 3. Okay, angle 0. Hindi, wag muna natin lagyan ng angle. Ito muna yung magnitude. Okay, so therefore, our voltage ng ating receiving end per phase is 230. Okay, so times 10 raised to 3 all over square root of 3. Okay, first step for this particular problem. Okay, so para mas madali, i-assume natin na yung receiving end voltage per phase natin is at reference, no? So assume mo. Okay, so in terms of the sending, sir, meron na tayong magnitude ng ating receiving end voltage. Okay, in terms of the sending end voltage, ito naman yung formula. Okay, magki-KVL lang kaya ako. Okay, so KVL. Okay, the sending end voltage per phase is just equals to, okay, yung voltage drop across our line impedance, okay, which is actually equal to the sending end current, which is also equal to the receiving end current. Okay? Sir, bakit equal sila? Series lang naman sila, no? Connected sila in series. Therefore, yung current sa sending natin, o sending end current natin, is just equal to the receiving end current per phase natin. Okay? Sir, hanapin muna natin yung current. Okay? So, formula lang ng ating per phase ng source natin is the current ng receiving end per phase multiplied by ZL. Yung voltage drop yan dito, no? Okay, plus syempre yung voltage ng ating receiving end voltage. Okay, sir, meron na ako nito. Hanapin ko na to. Ito kasi kailangan natin to get the voltage regulation. Okay, sige, hanapin muna natin yung current ng ating receiving end per phase using this formula. Okay, so our total apparent power sa load natin per phase, hindi per phase, no? The total load, okay, is just equals to the square root of 3 VLIL. Okay, so direct formula. Okay, therefore, our IL is just the total apparent power, SL, all over square root of 3 ng line voltage natin. Okay, but take note, since Y connected tayo, okay, the line current in Y connected load is just equals to the, okay, per phase current natin. Okay, kaya pag sunod natin yan, automatic yun din yung magiging receiving end current per phase naman. Okay, so bakit sila equal? Connected sila in Y. Okay, naka-series yung component. Okay, so apparent power binigay ba? Okay, sir, hindi binigay yung apparent power. Pero our apparent power is just equals to the real power divided by power factor. Okay, therefore, the receiving end current per phase is just equals to, okay, so power natin, 100 megawatt divided by the power factor, which is 0.9, all over square root of 3 ng line voltage natin, which is 230 kV. Okay, sir, ilan to? Okay, so computing mo muna. Okay, so 278.92. Okay, of course, no, kailangan natin ng angle dyan. Kasi, in terms of the sending end voltage, kailangan natin siyang solve in complex. Okay, so masosolve lang natin siya in complex, no? Okay, so tuloy lang natin. Okay, ano ba yung binigay sa problem? Pick upin ko lang. Sorry. Okay, our drawing ko na lang din. ZL load impedance. Okay, so ito ay our receiving end per phase voltage, which is just equals to 230 times 10 raised to 3 all over square root of 3 angle 0. While our current per phase naman daw, sinabi sa problem, is just equals to, so nasolve natin to, 278.90 o 9 ampere. Okay? So para makuha natin yung angle niyan, okay, since ang sinabi sa problem, okay, our load is operating at 0.9 lagging. Okay? Therefore, no, so with respect to the loading, okay, so ito, yung mnemonics muna natin, si Ellis. Okay, sabi kapag daw inductive in nature yung loading, inductive, no? Okay, it will give us the lagging power factor. Okay, ibig sabihin sir, kung lagging siya, okay, so our voltage E will leads, no? Our current. Pag drawing niyo yung phasor niyan, ito yung phasor na, itsura ng phasor niyan. Since yung voltage ng ating receiving end is nasa angle 0, okay, therefore yung current natin nahuhuli, okay, nasa ilalim pa siya. So mga banda dito yan. Ito yung ating current. Okay, and yung angle between dyan is actually our power factor angle. Okay, since ang binigay na power factor, 0.9, therefore theta, which is the power factor angle, is arc cosine ng 0.9. Okay, which is just equals to, arc cosine ng 0.9 is 25.84 ampere. Okay, so ano pa? Ampere tuloy degree. Okay, therefore, our receiving current per phase is just equals to 278.9. Angle, sir, ano yung angle natin? Dapat negative. Okay, negative yung angle natin. Okay, so 25.24 ampere. Okay, so bakit minus? Kasi nga leading. Leading yung voltage. Okay, therefore, yung voltage sending natin is just equals to, okay, voltage sending per phase natin is just equals to, okay, the receiving current per phase multiplied by the line impedance plus the receiving voltage per phase. Okay, sir, meron na ako nito. Meron na rin ako nito. Okay, hanapin ko yung ZL. Our ZL is in the form of R plus JXL. Okay, so may binanggit ng R. No? So sabi sa problem 22, our resistance per phase, no, per phase lahat yan, ha? Is just equals to 0.62 ohms. While our inductance L naman per phase is equals to, okay, so 93.24 millihenry. Okay, therefore our XL is just equals to 2 pi Okay, so XL, kayo na bahala. Okay, so 2 pi times 6 frequency times our L, which is 93.24 millihenry. XL, pag na-compute nyo yan, okay, compute natin. Okay, so 35.15. Kaya yung ating, ito na, line impedance per phase is 0.62 plus J 35.15. Okay, so ano pa sir? Okay, meron na tayo nito. Hanapin na natin tong sending end voltage per phase natin. The sending end voltage is just the resistance, the current, ng receiving per phase natin. ZL. Our ZL is 0.62 plus J 35.50 plus the receiving voltage. Okay, the sending end voltage, therefore, one three seven 497.6 angle 3.6. Okay, ito yung magnitude natin, no? So, yun lang yung pipick upin natin. Okay, so our percent voltage regulation is just equals to, okay, the sending end voltage natin. So, 137,497.6 minus the receiving end voltage natin, which is, ano yun, 230 times 10 raised to 3 all over square root of 3 all over 230 times 10 raised to 3 all over square root. Okay, so para makuha maging percent voltage regulation yan, okay, so times 100%. Okay, so ang lalabas na sagot dito is 3.54%. Okay, syempre yung pipiliin yung pinakamalapit. Okay, so ang pinakamalapit dito sir, ang pinakamalapit is letter C, no? So 3.50. Okay, so letter. Okay, so huwag nyo kakalimutan yan. Okay, so first assumption, nasa angle 0 yung receiving end voltage, compute current, then compute yung sending end voltage. Tapos magnitude formula kapag kakukunin yung voltage regulation natin. Okay? Next, problem number 23. Okay, one-way communication is called, okay? So one-way method of communication is also called the simplex method. So letter. Okay. So next. Okay, in 2 watt meter method of power measurement, the readings of the 2 watt meter is 6717 and 2658 respectively. Find the power factor. Okay, so in 2 watt meter method, so ito real power, apparent power, and real power, reactive power, and ST. Okay, so for a 2 watt meter method, okay, so tangent theta is just equals to the square root of 3, QT all over PT. But our total reactive power, direct formula, kapag balance is just equals to square root of 3, watt meter reading 1 minus watt meter reading. All over, okay, so the power total, sir, power total natin is, okay, the sum ng watt meter reading natin. Okay, since ang pinapahanap is power factor, our power factor is cosine theta. Okay, so hanapin niyo yung theta, then mahanap yung power factor. Okay, so therefore, our theta is arctangent ng square root of 3, watt meter reading 1, 6717, minus 2658 all over the sum ng dalawa. 6717 plus 2. Our theta, therefore, is just equals to, okay, so arctangent ng square root of 3, 6717 minus 2658, 6717 plus 2. Okay, so 36.87. Okay, therefore, power factor is cosine ng 36.87. Okay, so 0.8. Okay, so tamang sagot, letter. Okay, of course, no, so kung gusto niyo malaman yung nature ng power factor, okay, lumabas pa rin siya ng actual. Okay, so lumabas pa siya ng actual. No? So, since the wattmeter reading 1 is greater than the wattmeter reading 2, under the assumption na ABC sequence, okay, and common node nito is C, no, nung sinukat yung, nung ginamit yung wattmeter, okay, so positive sequence, lagging daw. Okay, syempre, vice versa, if the wattmeter reading 1 is greater than W2, less than W2, lagging naman. Okay, under the assumption na positive sequence, where the common node is yung C. No? So, doon sa ABC na. Okay? So, yan yung problem number 24. Okay? So, next. Problem number 25. Okay, problem number 25, lumabas noong September 2022. An ACSR conductor has 7 steel strand and surrounded by 24 aluminum conductors. It's specified as, okay, sir, no? Specification yan, conductors per strand lang. Eh? Number of conductors, which is 24, per strand, which is 7, ACSR. Kaya ang tamang sagot dito, letter D. Okay, conductors per strand. Okay, so letter D. Next. Problem 26. No? So there are no transient in pure resistive circuit, okay, because blank. Okay, so tatandaan, nagkakaroon lang tayo ng transient response, okay, transient. Kapag ka may either or both, no, LNC na. LNC component tayo. And LNC is those components who can store energy. Okay? So magkakaroon ka lang kasi ng transient response kapag meron kang LNC. Okay, therefore dito, since ang pure resistive circuit natin, okay, walang LNC kasi nga pure R siya. Therefore, kaya wala tayong transient dito kasi nga they don't have stored energy. Okay, so letter C. Okay, so LNC lang kasi yung nagre-response, no? So between the main components, inductor, capacitor, and resistor, si LNC lang yung nagre-response doon sa transient period natin. Or doon sa transient sa transient period natin, no? So yung initial, yung pagkakasaksak mo lang o kakahugot mo lang ng ating source, no? So pwede. Okay? So tamang sagot dito, there are no transient in pure resistive circuit, letter C, have no stored energy. Okay, so letter C. Okay, next. The next question, a coil of copper wire has a resistance of 5.46 at 75 degree. What will be the resistance at 25 degree? Okay? So dito, no, so temperature resistance relation lang. Okay? So pwede kayong gumamit ng dalawang formula. Okay? So dito, ito na lang formula natin. Sige, lista muna natin. Let R1 is equals to 5.46 ohm. Okay? At a temperature T1 which is 75 degree. Okay, hanapin daw natin si R2 where the temperature T2 is just equals to 25 degrees. Okay, so dito, ito yung formula ng gagamitin. The ratio of the resistance R2 all over R1 is just equals to the inferred absolute temperature, okay, nung ating material plus T2 all over the inferred absolute temperature plus T. Okay, sir, meron na ako nito. Ang hinahanap is R2. Ang wala na lang ako, the inferred absolute temperature. Okay. So madalas o minsan hindi binamagsak sa problem yung ating inferred absolute temperature, especially dun sa mga common material natin. For copper, the inferred temperature natin dito is negative 234.6 degrees Celsius. Okay? Kaya pag sinubstitute natin yan dito sa formula natin, R2 is unknown all over R1. Sir, R1 natin 5.46 is just equals to the absolute, no, inferred absolute temperature which is 234.6. Plus T2, sir, T2 natin, 75 degree. 25 degree. Okay, plus, all over, 234.6 plus 75. Okay, kaya lalabas ang sagot dito. Okay, so pag sunod natin yan is letter D. No? So 4.58 ohm. Okay, so letter. Okay, so yan yung problem number 27 natin. Okay, next. Problem 28. Okay, the power factor angle in a three-phase system is the angle between blank and blank. Okay, so in terms of power factor angle, the power factor angle is the angle difference between the voltage and current. Okay, kapag three-phase yung system, well defined dapat yan. Okay, kapag three-phase yung system, the power factor angle should be the voltage per phase natin o the angle ng per phase voltage, okay, minus no, yung corresponding phase current natin. Okay, so phase voltage and phase current dapat yung ipagkukumpara natin. Okay, so phase voltage and phase current, so letter C. Okay, so power factor. Okay, so next. Okay, problem number 29. Okay, a 4-pole generator, 500 conductor on an armature. If the generator is running at 1,2, okay, so hinahanap is the average EMF if the flux per pole is 10 raised to 6 9. Okay, so direct formula for DC generator, the EMF generated is given by this formula, PZ flux N all over 68. Okay, take note, yung flux natin dito should be in Weber. Our speed here should be in revolution per minute. Okay, P is the number of poles, Z is the total conductors, and A is actually the number of parallel paths. Okay, so the number of parallel paths A, since ang binanggit sa problem, ano ba sinabi niya? 4-pole generator lap. Okay, kapag lap, the number of parallel paths A is given by this formula, M times P. Okay, but since hindi binanggit sa problem kung ano yung multiplicity factor natin, i-assume natin na simplex yan, which is equals to 1. Multiplied by P, where P is the number of poles, 4. Therefore, A is just equals to 4. Okay, so direct formula. Ito lang yung direct formula natin. So, check muna natin. Yung flux na binigay is naka-lines pa. Okay, convert natin into Weber. Okay, flux is 10 raised to 6 lines. Which is just equals to, pag convert natin, no? 1 Weber is just equals to 10 raised to 8 lines or Maxwell's. Okay, so pagka kinuha natin yung flux in Weber, it is actually 1 all over 100. 10 raised to 6 divided by 10 raised to 8. No? So 6 minus 8 is negative 2. Okay, so 1 all over 100 Weber. Okay, so yung speed ba natin naka-RPM? Naka-RPM. Okay, therefore, direct formula. Hour is the number of poles for, now total conductors 500. Flux is 1 all over 100 or 0.01. Okay, number of speed is 1,200 all over 60 times yung number of parallel paths, which is 4. Okay, therefore, EMF is just equals to, okay, pag sinob nyo yan ang lalabas, 100 volts. Okay, so letter A. Okay, yan yung problem number 29. Sorry, tama, 20. Okay, so next. Okay, so next problem, a circuit that removes positive or negative or part of a positive or negative parts of the waveform is also called as, okay, so clipper circuit. Okay, so part lang naman. No? So for example, meron tayong sinusoidal wave. Okay, so kung i-clip mo o tatanggalin mo lang yung part ng ating positive or negative sine wave, no? So puputulin mo lang. Okay, so ito, ang gamit natin dyan, no, para maputol yan is actually clipper circuit. Okay, so letter D. Okay, next. Okay, next problem. Okay, problem number 31. Okay, for this problem number 31, it is actually output power ng ating hydroelectric power plant. Okay, the output power for a hydroelectric power plant is just equals to the efficiency Q gamma H. Okay, where Q should be in meter cube per second. Okay, gamma, no, so pag hindi binanggit is 9,810 Newton per m cube. And yung height should be in meter. Okay, of course, yung gamma natin dito, okay, pag hindi binanggit, yun yung gagamitin natin. Okay, pero pag may density na binigay, kukumputin nyo pa yung gamma. Okay? Where our efficiency here is just the product of all the efficiency, no? So, total efficiency or overall efficiency is just equals to the turbine efficiency multiplied by the generator efficiency, which is just equals to 0.8 times 0.25. 0.95. Okay, sige. 0.8 and 0.95. 0.76. Okay, so formula, the output power, therefore, is just equals to the efficiency, sir, 0.76. Our Q, so may binigay bang volumetric flow rate in meter cube per second? So may binigay, no? So 1 meter cube per second. Gamma natin is 9810 and yung height daw natin 60 meter. Yan o, 60 meter. Okay, so ang lalabas sa sagot dito is in watts, syempre, no? So 0.76, 9810, 60. Okay, so 447. Okay, so times 10 raised to 3 watts. Okay, in kilowatt, 447 kilo. Okay, so letter E. Okay, yan yung problem number. Yan, kilowatt. So 31. Okay, so next. Okay, next problem. Problem number 32. Which of the following is not the qualification for ERC? Okay, so tamang sagot dito. Letter D. With at least 5 experience, no, hindi siya qualification ng PRC. Okay, so letter D. And distinguished experience in their respective field of expertise. Okay, so hindi yan included. Okay, so letter D. Okay, next. 33. Okay, problem 33, a flat coil of wire having 5 turns and has an inductance L. The inductance of the similar coil having 20 turns is blank. Okay, so kapag may inductor tayo, okay, so inductor, okay, so kapag nagdadagdag lang kayo ng number of turns, okay, ito yung ating formula dito. So, condition 1, L1 with a number of turns N1. Ito naman, sir, L2 and okay, so formula natin or relation natin, the ratio of the inductances, L1 and L2, okay, is just equals to the ratio of our number of turns or turns natin, which is N1 and 2 squared. Okay, so nabi sa problem, okay, yung first inductor daw natin, ang inductance value is just equals to L. Okay, therefore, L all over L2 is just the number of turns nung nauna, which is 5 all over 20. Okay, pag sunod natin to, sir, our L2 is just equals to 16L. Okay, so 5 all over 20 is 1/4. 1/4 square is 1 all over 16. L2 therefore is 16L. Okay, so problem number 33, letter C naman. Okay, so letter C. Okay, next. Okay, next question is 30. Okay, problem number 34, sabi, a single-phase transmission line 35 km long consists of 2 solid round conductors, each having a diameter of 0.9 cm. The conductor spacing is 2.5 meter. What is the value of inductance per inductor? Per conductor. Okay? So dito, so sa mga problem na ganito, laging dalawang possible yung inductance sa pinapakuha. Yung inductance ng loop o total inductance natin or inductance ng ating per conductor. Okay? Kapag per conductor, ito yung formula. Okay, the inductance per conductor is just equals to 2 times 10 raised to 7, negative 7, I mean. Okay, ln of our D all over D. Okay, so ang unit natin dito, sir, is Henry per meter. Okay, so our D, okay, since single phase to, sir. Okay, so distance between conductor is 2.5. Okay, our D is just equals to the square root of n multiplied by the distances. Okay, therefore, the D is just equals to the square root. Sir, dalawa lang naman yan eh. From 1 to 2, 2.5. Okay, from 1 to 2, 2.5. Okay, from 2 to 1, 2.5. Kaya yung D natin kapag single phase, yun lang din yung distance between conductor. Okay, so 2.5 meters. Okay, for our D sub S for this particular formula is actually our geometric mean radius. Okay, our GMR, direct formula, is just equals to e raised to negative 1/4, okay, multiplied by the radius ng conductor. Okay, sir, ano ba yung radius ng conductor na binigay? Okay, the radius of the conductor, o diameter muna, The diameter of conductor is 0.9 cm. Okay? So, convert nyo muna to. Okay, papuntang meter. Okay, kasi meter to sir, no? Para mag-cancel. Okay, so 100 centimeter per 1 meter. So, cancel lang to. So, magiging 0.009. Okay, therefore, our radius is just equals to d all over 2. Okay, where d is 0.009 all over 2. Okay, equal to sa 0.0045. Okay, therefore, our GMR is just equals to yung e raised to negative 1/4 na yan, equal lang din yan sa 0.7788. Okay, depende kung saan kayo masanay, no? Okay, so masanay ako dito sa 0.7788 kapag nagsosolve ako, no? So 0.7788 multiplied by our radius ng conductor which is 0.0045 meter. Okay, so wag na natin siyang simplify, no? Hayaan nyo na lang na ganyan yung value. GMR is 0.788 times 0.045. Okay, so computin na natin yung L. Our L1, therefore, or inductance per conductor is just equals to 2 times 10 raised to negative 7 Ln ng ating D, where D is 2.5 meter, all over our GMR. GMR, sir, 0.7788 times 0.0045. Okay, in Henry per meter. So, pag sinolve natin to, okay, so 2 times 10 raised to negative 7, Ln ng 2.5, all over 0.7788 times 0.004. Okay, so ang lalabas is 1.314. Okay, so times 10 raised to negative 6. Okay, Henry per meter. Okay, so naka per unit length pa siya, no? So, copy lang natin yan. Okay, our L1, ako na ilagay ha. Okay, sir, na-complete mo na yung L1. L1 is just equals to 1.314 times 10 raised to negative 6 Henry per meter. So, para makuha niya yung inductance per conductor, okay, so, given 35 kilometer, i-multiply nyo lang yung length, okay? Yung length natin, dito ko ilagay yung L natin, which is 35 kilometers, is just equals to 35,000. Okay? Therefore, the total inductance is, multiply nyo lang sa total length, 35,000 meter. May cancel yung meter, ang matitirang unit is a unit of inductance in Henry. No? So, times 35,000. Okay, so it is actually equal to, so pagka scientific notation, okay, so 40, ito muna. Okay, 45, okay, 0.99 times 10 raised to negative 3 Henry, which is equals to, okay, approximately 46 millihenry. Okay, so letter E. Okay, so yan yung problem number 34. Okay, next. Okay, problem number 35. Okay, problem number 35. In electric field, the potential is work done in those, okay, tamang sagot letter A, to bring the positive charge of one column from infinity to that point. Okay, so letter. Okay, so next. Okay, a two-pole alternator is 1,500. What is the angular velocity? Okay, so mapapansin nyo, no, naka per second muna sila lahat. Convert muna natin yung revolution per minute to second. Okay, so our speed in RPM, so 1,500 revolution per minute. Convert nyo lang papuntang revolution per second. 1 minute per 60 second. Okay, so 25 rev per second. Okay, or RPS. In terms of angular velocity is just equals to 2 pi. Okay, so kung naka per second yung rad per yung ating angular velocity, dapat naka revolution per second yung ating speed. Okay, so 2 pi times 25, which is just equals to 157.1 rad per second. Okay, kapag nag-multiply kayo ng 2 pi dun sa ating RPM o yung speed natin, okay, so automatic magiging angular velocity yan. Okay, so 1 rad per second. So letter, yung problem to, 35, 36. Okay, so letter C. Okay, so yan lang naman. So, easy lang siya. Okay, next. The next problem is problem number 37. Okay, so a 200 kVA transformer has an iron loss of 1 kilowatt and full load copper loss of 2 kilowatt. What is the percent load at maximum efficiency? Okay, so with respect to transformers, okay, to attain yung ating tinatawag na maximum efficiency, isa lang yung condition na binabantayan natin. Okay, o isa lang yung mahalagang condition, that the iron losses, okay, which is a constant loss, should be equal to our copper losses at particular loading X. Okay? Sir, no sir, ano ba yung iron loss natin? Our iron loss is 1 kilowatt. Okay, therefore, dapat ito yung copper loss natin at any loading, at a certain loading X, at a certain loading. Okay, so at a certain loading. Okay, so kapag yung X nyo is just equals to 0.5, half load. Kapag 1, full load. Okay, pag 1.25, 25% overload siya. Okay, so dito, so alam ko na dapat yung copper loss ko during the maximum efficiency. So ano ba yung direct formula ng copper loss natin at any loading with respect to the full load copper loss natin? Okay, so the copper losses natin at any loading X is just equals to loading square multiplied by the copper full load loss natin. Okay? Sir, ano ba yung ating hinahanapan ng loading? Okay, so the PCUX natin, which is 1 kilowatt, is just equals to loading square multiplied the copper full load. Sir, copper full load loss is 2 kilowatt. Okay, so pag sinolve natin yan ang lalabas, our X is 0.707, okay, 1, or 70.71%. Okay, kapag ni-round off niyo yan to the nearest integer, 71%. Okay, kaya ang tamang sagot, letter A. Okay, so letter A, 71%. Okay, so basta tatandaan nyo, okay, with respect to the relation ng copper full load natin, X to the copper full load, to the copper loss natin at any loading X, and also the copper full load natin, ito lang yung formula ng gagawin. Okay, absolutely. Okay, so madalas lumalabas yung mga ganitong tanong, no? So hindi naman sa madalas, pero kung usapang transformer, ito yung mga lumalabas madalas. Okay, so percent efficiency, percent loading during maximum efficiency, core losses, din yung mga lumalabas. Siyempre, pati yung mga relation ng primary and secondary. Next. Okay, next problem is problem number 38. Okay, problem number 38 sabi, okay, an electric heater takes 1.2 kilowatt hour in 30 minutes at 120 volts. What is the current input? Okay, so may binanggit dito, no, yung itong 1.2 kilowatt hour, it's actually our energy. Electrical energy is just equals to 1.2 kilowatt hour. Okay, but take note una, power is just equals to current multiplied by the voltage. Okay, and our electrical energy naman, sir, is power multiplied by time. Okay, therefore, electrical energy is just equals to power, but my power is just current multiplied by the voltage times time. Okay? Kaya kung gusto nyo makuha yung current natin dito, our current is just equals to the electrical energy all over voltage times time. Okay? So, sir, meron na ba tayong energy? So, meron na, sir. 1.2 kilowatt hour, which is actually 1.2 times 10 raised to 3 watt hour. All over the total voltage, sir, voltage natin, 120 volts. The times our time. Okay, so mapapansin nyo, ang unit ng time nung nasa numerator is in R. I-convert ngayon natin yan, yung ating binigay o yung given sa problem into R para magka-cancel sila. No? Okay, so yung time natin, T is equals to 30 minutes. Okay, pag kinonvert nyo yan papuntang R, okay, 60 minute, okay, 60 minute per 1 hour. Okay, syempre, no, 0.5 hour lang. Okay, therefore, our T here is just 0.5 hour. So, magka-cancel yung R, and power per unit voltage is just current. Okay, watt all over voltage is current. Okay, kaya ang tamang sagot, 20 ampere lang. So, letter D. Okay, so letter D. Okay, next. Okay, next question is problem number. Ba't na doble po? Okay, problem number 39. The rotor power developed at no load in an induction motor is equal to blank. Okay? So kapag nag-refer tayo sa power flow diagram ng rotor natin, rotor side lang ng induction motor, ito yung rotor side power flow natin. Okay, the input power rotor, okay, the copper losses rotor, okay, the power developed, rotational losses, zero, and output power. Okay, so pag tinignan natin o kinuha natin tong portion ng ating power flow, therefore, power developed is just the sum ng P rotational losses, okay, or rotational losses, I mean, plus output. Okay, so binanggit sa problem, the rotor power developed at no load is blank. Okay, so at no load, sir, yung output natin is 0. Kasi nga, wala tayong load dun. Okay, therefore, kung mapapansin nyo, during no load, the power developed is just equals to the P rot, which is the rotational losses. Okay, so letter, okay, ito yung equal siya no, sa rotational loss. Okay, so yan yung problem number 39 natin. Okay, next. Okay, problem number 40. Okay, so a 50 kVA alternator operates a full load kVA output at efficiency of 93.5. Okay, percent. If the load power factor is 0.83, calculate the total. Okay, so in terms of efficiency formula, okay, our efficiency formula is just equals to output. Okay, of course, marami kayong way no, para ma-express nyo to. Basta lagi yan, galing sa output all over input. But our input is just equals to the output plus all the losses, plus P loss. Okay, so may binigay ng efficiency, sir, 93.5. Okay, ang nawawala na lang actually sa akin is output power, no, para ma-solve ko yung losses. Okay, so yung binigay dito is yung output apparent power, S out. Okay, the output apparent power which is 500 kVA. Okay, para makuha natin yung output real power natin is just equals to apparent power multiplied by the power factor. So 500 multiplied by 0.83. Okay, so pag sinulog nyo yan, the output power is just equals to, okay, 415 kilowatt. Okay, sir, meron na akong output. Okay, pag sinubstitute ko na yung output power na yan dito, our efficiency, which is 0.935, is just equals to the output power, 415 kilowatt, all over 415 kilowatt, plus all the losses. Okay, since kilowatt to, ito rin sir kilowatt, automatic yung losses, syempre naka-kilowatt yan. Okay, our losses therefore is approximately 29 kilowatts. Okay, next. So letter D. Okay, so letter D tuloy. Next problem is problem number 41. Okay, in a transformer, the core loss is found to be 60 watts at 30 Hz, 90 watts at 40 Hz, measured at the same maximum flux density. Compute the eddy current and hysteresis loss at 60 watts. Okay, so dito, sulat lang muna natin yung direct formula nila. Okay, the hysteresis loss, ito yung formula. Okay, so N BM raised to 1.6. F. Okay, eddy current naman, sir, ito. Aha. Sorry. Nililipat. Okay. So, raised to 2. Okay. So, F squared is B squared. We take note, no? So, with respect to the core losses, our core losses sa transformer is just equals to the hysteresis loss plus the eddy current losses. Okay. So, dito, ang pinapahanap is the eddy current at 60 Hz. Okay. So, based sa formula ng hysteresis loss, okay, yung ating N dyan, or yung letter na to is actually, okay, nakadepende sa material. Okay, yung flux natin is constant. yung V natin, which is the volume, is constant. Therefore, this K constant or this value is treated as a single constant. Okay? So, ibig sabihin kasi, kung mapapansin nyo, nagpapalit-palit lang o nagbabago-bago lang dito is yung ating frequency. Okay? Kaya other than the frequency, treated na siya constant. As a constant dito sa formula. Okay? Therefore, the hysteresis loss is just a certain constant A. Ito yun ha. Pinagsama-sama ko. Multiplied by my frequency. Okay? So, with respect to the eddy current naman, itong K sub E natin, nakadepende sa material, flux is constant. Okay? Yung volume ng ating core, constant din siya. Therefore, okay, so itong tatlong to is treated as a single constant B. F squared. Okay? So ngayon, no, so for this particular problem, okay, so ite-table nyo lang, no, para mas madali. Okay, so ano ba yung binigay ng frequency? Tatlo. Okay, at 30 Hz, at 40 Hz, and at 60 Hz. Okay, ito sir, hysteresis. Ito naman sir, eddy current. Of course, yung total nila is the core. Okay, so ano may sinabi? The hysteresis loss at 30 watts, which is, ano bang value ng, ano bang formula ng hysteresis natin? A multiplied by the frequency F, which is 30, plus our eddy current, which is actually B, multiplied by ito na, F square, which is 30 squared. Okay, so pag sinum down natin yan, core losses yan, okay, our core losses at 30 Hz is 60 watts. Okay, at 40 Hz naman, so A multiplied by 40, plus B multiplied by 40 squared, is just equals to my core loss, which is 60. Okay, sorry, which is 90. Okay, so anong pinapaano sa problem? The hysteresis loss, okay, which is actually A times 40, and our eddy current loss, which is actually B times, A times 60, I mean, and B times 40. Okay, B times 60 squared. See, sir, ibig sabihin kailangan ko lang ng constant AN. Okay, so paano nyo makukuha? Okay, so mapapansin nyo dun sa dalawang frequency natin, 30 Hz and 40 Hz, meron tayong two equations, to ano. Okay, so makukuha na natin yung value ng AN. So two equations, to ano. Of course, nakadepende na sa inyo kung ano yung gusto nyo gamiting method of solution. Okay, syempre sa akin, calculator na. Okay, so pag kinalculator natin to, two equations to unknown ang lalabas. Okay, our A is just equals to 5 fourths. And our B is just equals to, okay, so 1 all over 4. Okay, so ito na yung constant natin. Okay, our A, or our hysteresis loss is A, where A is 5 fourths. Okay, times 60. So yung A natin ha, itong values na to, ito yung ginamit ko dito. Okay, which is just equals to, okay, so pag sinolve nyo yan, ang lalabas dyan, 75 watts. Kapag eddy current naman, sir, 1 all over 40 multiplied by 60 squared. Okay, so ang lalabas naman dito, 90 watts. Okay, so tamang sagot, okay. So 90 watts, eddy current, 75 watts, hysteresis loss. Okay, so letter. Okay, so letter A. Of course, no, itong problem number 41 na to. Okay, so lumabas na rin to, no? May nag-chat. Sino ba? Okay, sir, okay lang po bang bigyan po kaming time to copy solution after each problem kahit 15 to 20 seconds? Sige, pwede naman. Okay? O sige. So, okay, so dito sa problem number 41, okay, since itong problem na to is actually nasa handouts nyo na rin. Okay, nasolve nyo na to. Okay, so kung gusto nyo makita yung solution ng other problem, okay, or other given, I mean, okay, so nasa handouts na rin. Okay, yun na rin yung pinagbasihan namin dito. O pinagbasihan ko sa solution. Okay, so tamang sagot is letter A. So 90 and 75. Okay, so yun yung problem number 40. Okay? Copy mo. Okay? Ano pa ba? Okay? Okay, next. Next problem, problem number 42. Okay, lipat na natin. Okay, problem number 42. Okay, so, yun. In alternator, pitch factor is just the ratio, or is the ratio, I mean, of the EMF, so Kp yun. It is actually the ratio of the EMF nung short pitch coil EMF to full pitch coil. So, letter E. Yan yung Kp na. Okay, so kapag KD naman, actually ratio naman siya ng distributed. Okay, so distributed winding EMF to the concentrated winding EMF. Okay, kapag KD. Okay, pero kapag pitch factor, KP, it is actually the ratio of EMFs ng short pitch to full pitch coil. Okay, so kaya ang tamang sagot dito is letter B. Okay, so next. The next problem is 43. Okay, problem number 43. The initial rate of current rise in an RL circuit is 300 amp per second when 120 volts is suddenly impressed. Okay? So what is the inductance of the circuit? Okay? So dito meron daw tayong RL circuit. Okay, for this RL circuit, okay, wala namang binanggit na RNL. Okay, so sinabi dito, when is suddenly impressed. Okay, ibig sabihin tong circuit na to is actually, so laki-lakihan ko lang ng drawing konti, no? Initiation transient. Okay, so from the originally disconnected circuit, kinonect natin siya, no? Okay, so nagkaroon siya bigla ng current, RL. Okay, of course, din na natin i-discuss yung o sosolvein o i-derive yung direct formula. The direct formula for the current here, okay, o hindi naman current, no? Yung voltage across, okay, initiation transient to, no? So kung gusto nyo balikan yung mga formula, nasaan out nyo lang ng transient circuit or electrical transient. Initiation circuit, the voltage drop across my VL is just equal to, okay, the EMF nung source ko, E, multiplied by E raised to negative T multiplied by R all over. Okay? So, sinabi dito, the initial rate of current rise. Okay? So, pag sinabi natin initial rate, okay, meaning at time is equals to 0. Okay? So, at time is equals to 0, the voltage across inductor is VL, which is just equals to E. Sir, ang E natin is 120 volts. Okay, so 120 multiplied by E raised to negative 0 times R. Okay, regardless kung ano yung R and L, 0 pa rin siya. 0 times ang constant is 0. Okay, E raised to negative 0 o E raised to 0 is just equals to 1. A constant raised to 0 is 1. Okay, except 0, of course. Therefore, VL is just equals to 120 volts. Okay, so in terms of inductance, okay, makukuha natin yung inductance na yan, okay, using this equation. Okay, so the voltage across my inductor, magnitude lang to, is just equals to LDID. Okay, therefore, our L is just the voltage across the inductor divided by the rate of current per unit. Okay, so at time is equals to 0. Okay, the voltage drop across my inductor is 120. And the rate of current, which is the initial rise of current, is actually 300 ampere per second. Okay, kaya ang tamang sagot dito, okay, pag sinunod mo yan, 120 divided by 300, okay, it is just equals to 0.4 Henry. Okay, so letter D. Okay, sige, kopya muna. So, question. Okay. So, ano ba yung next question? Okay, so ano oras na? Okay, so kaya pa. Okay, so next question is problem number, problem na tayo, 44. Okay. Okay, problem number 44. Okay, sabi, an elevator is rising at a constant speed. Okay, consider the following statement. Okay, so 1, 2, to 4, to 5, I mean. Okay, so ano daw yung mga statement na true dyan? Okay, so in terms of elevator, okay, so elevator, dapat yan, so sinabi rin naman sa problem, sabi niya, rising at a constant speed. Therefore, yung velocity ko doon is just equals to o constant. Okay, syempre pag yung velocity natin is constant, acceleration natin is 0. Okay, kasi di umaangat o hindi bumababa yung velocity niya, no? So acceleration is 0. Okay, so for this, no, so hanapin niyo lang yung mga statement na okay, i-describe tong dalawa, which velocity is constant and acceleration is. Okay? So dito yung statement 4, okay, the acceleration of the elevator is 0. Okay? So kasama siya. Okay? Kaya ang tamang sagot dito or ang possible na tamang sagot na lang is letter B and letter D. Okay? So doon naman sa statement 1, the upward cable force is constant. Okay? So check din yan. And the kinetic energy of the elevator is constant. Sir, ano ba yung formula ng kinetic energy? Kinetic energy is 1 half mv square. Sige, sulat ko na lang din. Ngayon, kapag constant yung velocity ko, o yung ating kinetic energy, dapat constant din yung velocity ko. Therefore, analogous lang siya, or di siya analogous actually. Ang hidden thought ng ating statement 2 is constant velocity din. Kasi nga, constant yung kinetic energy natin. Okay? So, kaya ang tamang sagot dito, so tatlo yan. Okay? Statement 1, statement 2, and statement 4 are correct. Okay, so letter. Okay, so tamang sagot, letter B. Okay, so syempre tanggalin ko na yung B, no? So, B. Okay, question dito. Okay, so next. Okay, next problem, problem number 45. Okay, problem number 45. Transmission voltage level of 1,000 kilovolt okay, is categorized as blank. Okay, so sa PGC natin, okay, so Philippine Grid Code natin, okay, yung voltage level natin, okay, is naka-define lang until extra high voltage. Okay, from the low voltage to extra high. Okay, kasi nga, no, so hindi pa nila dinedefine yung ultra high voltage kasi wala pa namang ganong voltage level sa atin. Okay, so take note, ang pinakamataas lang na transmission voltage natin, okay, sa Pilipinas is 500 kilovolts. Okay, and 500 kilovolts is under the extra high voltage category. Okay, with respect to the ultra high voltage category, okay, so ang range dito ng voltage is around, okay, so 700, anything above 765 kV up to 1,000 kilovolt. Okay, kapag yan yung voltage mo, under ultra high voltage yung ano mo, category mo. Okay, kaya ang tamang sagot, letter D. Okay, so syempre no, hindi nyo mababasa sa PGC yan. Okay, hindi pa kasi available yung voltage level na ganyan sa atin. Okay, so up to 500 kV pa lang pa. Okay, so sa ibang bansa, no, sa China, okay, sa US, okay, meron silang ganyan, no, ultra high voltage, which is up to 1,000 kV. Okay, sa Pilipinas, hindi pa siya naginagamit. Okay, so sa board exam, tatandaan nyo, okay, so lumalabas din yung mga voltage classification level mo. Okay, kaya kakabisaduhin nyo rin or dadaanan nyo rin dapat. Okay, huwag nyo kakalimutan. Okay, so problem number 45 is ultra high voltage. Okay, so letter D. Okay, so next, problem number 46. Okay, problem number 46 sabi, a medium unshaded lamp hangs 8 meters directly above the table. Okay, to what distance should be it lowered to increase the illumination of the 2 times its former value? Okay, so meron daw tayong lamp. Okay, so ang distance daw ng kanyang iniilawan, so sabihin ko na lang mayroon siyang area na iniilawan, which is R1 is just equals to 8 meters. Okay, siyempre may intensity yung ating lamp. Okay, I1. Ito naman yung illumination natin sa surface. Okay, ngayon, ano daw yung distance ng ating object? Okay, such that, so ito yung object natin ha. Yung R2 yung hinahanap, such that yung illumination daw na mabibigay o may experience ng area natin o yung iniilawan natin is twice ng original illumination. Okay, siyempre may intensity item. Okay, so kapag ganyan, no, hindi nagbabago yung lamp, okay, ang binabago lang is yung distance ng ating iniilawan, constant yung intensity natin. Okay, so of course, ang gagamitin natin ditong formula is the inverse square. Okay, so our illumination E is just equals to I all over R squared. Okay, therefore, our I is just equals to E multiplied by R squared. Okay, where E is illumination. Okay, so alam nyo na yan. Multiplied by our R, where R is the distance ng ating, o direct distance ng ating light, okay, doon sa surface natin. Okay, since hindi nagbabago yung ilaw, constant intensity, our I1 should be just equals to I. Okay, but our I is just equals to ER square, which is E1 R1 square, equal to E2 R2 square. Okay, so E1, sir, is E1. Okay, our R1 is 8 meter square, 8 meter square, tama? Okay, sabi, ano daw yung R2 natin such that the E2 is twice ng E1. Therefore, E2 is 2E1 multiplied by R2 square. Okay, so pag sinolve niyo yan, our R2 is equals to, okay, so 5.66 meters. Okay, so letter B. Okay, next. Okay, so electric field lines are trajectories. Electric field lines is blank. Okay, so letter E, trajectories of test charge, vectors in the direction of the electric field, form closed loop. Okay, so A, B, and C is not the characteristic or are not the characteristic of electric field lines. Okay, kaya ang tamang sagot dito is letter B, no? So none of this, so letter. Okay, so question. Okay, so next. Oras na ba? Okay. So next question, the last question before break. Okay, so problem number 48. Okay, an electric field, no? So may value daw siya, 200 Newton per coulomb. Okay, in positive x direction, the force of electron in this field is blank. Okay, so dito, so our E is just equals to 200 Newton per coulomb. Okay, so based dun sa unit natin, pwede natin sabihin that our E, okay, Newton is a unit of force, while C is a unit of charge. Okay, electric field is just force divided by our charge. Okay, so ngayon dito, since ang binanggit sa problem is electron, okay, for a single electron, 1 electron, okay, so ano ba yung value ng charge mo? It is just equals to, so 1.602 times 10 raised to negative 19 coulomb. Okay, itong constant na yan, nasa calculator din yan, no? Constant number 23. Okay, for a single electron, it contains a charge of 1.602 times 10 raised to negative 19 coulomb. Okay? Kaya pag pinapahanap is yung force, our force F is just equals to the field multiplied by, electric field multiplied by our charge. Okay? Therefore, sir, yung eco is 200 Newton per coulomb, while yung charge ng electron ko, ito na yan is just equals to 1.602 times 10 raised to negative 19 coulomb. Okay, so times 1.602 times 10 raised to negative 19 coulomb. Okay, so cancel yung coulomb. Kaya yung matitirang unit is a unit of force, which is approximately, okay, so 200, 1.602. Okay, so 3.2 times 10 raised to negative 19 Newton. Okay, so in terms of the direction, okay, so kung ipa-plot natin yung itsura, okay, our electric field is here. Okay, so 200 Newton per meter. While sabihin na natin ito yung electron ko, and electron is in terms of sign or nature niya, no, is negatively charged. Okay, so kung ang ating field is in direction of the positive x direction, okay, so ma-attract siya dito sa ating electric field. Okay, so syempre, no, kabaliktaran yung kanyang direction. Okay, kaya ang direction niya dito is actually, so kung yung field natin is towards to the positive x direction, our electron will be attracted. Okay, so therefore, ang direction niya is into the negative x direction. Okay, so negative x direction. Okay, kaya ang tamang sagot dito, 3.2 times 10 raised to negative 19, okay, negative 17 I mean, Newton at negative x direction. Okay, so letter D. Okay, so question dito sa problem number 49. Okay, so sige, no? So kung wala mo ng tanong, okay, so kung wala ng tanong, okay, so let's have a break. Okay, and then tuloy natin, start tayo ng round. Okay, Okay, so tuloy na natin, no? Okay, so next problem. Sorry. Okay, problem number 50. Okay, so sabi sa problem number 50, in which type of faults given below, all the three components IA0, IA1, and IA2 are equal. Okay, so for a SLG or single line to ground fault, okay, so quick lang ha. Quick. So three-phase supply. Okay, so ito yung tatlong lane na natin. Okay, so IA, IB, and IC. Okay, so considering during SLD, okay, okay, so yung isang line natin, so sabihin na lang natin yung line A natin is yung faulted line natin o yung kumonekta sa ground. Okay, so may magpo-flow na fault current. Okay, so tatandaan natin, okay, so our current will always choose the path of least resistance. Therefore, yung current dun sa BNC natin is approximately equal to 0. Okay, syempre may leakage pa rin siya, no? May konti pa rin kuryente. Okay, so during the single line to ground fault, okay, so according kay Fortescue's theorem, ito yung mga components niyo, no? So IA0 is just equals to 1/3, okay, and yung sum ng tatlo. IA, IB, and IC. IA1 naman, sir, just equals to 1/3, okay, so IA plus A square IB plus A IB and A square IC. Okay, while yung IA2 naman, sir, is just equals to 1/3 IA plus A square IB IC. Okay, since under SLB, okay, the fault, no, so under this representation, current B and C are equal to 0. Okay, so 0 na to. 0 na rin tong buong to. Okay, mapapansin nyo yung formula ng ating IA0, IA1, and IA2 pare-parehas na, no? So it is just equals to 1/3 multiplied by IA, where IA is actually our fault current IF. Kasi nga, okay, so isa na yung dumadali sa akin. IA is just equals to during the single line to ground fault. Considering yung line A natin yung faulted line. Okay? So tamang sagot dito, SLB. Okay? Of course, no? So line to line fault, three-phase fault. So three-phase fault is also known as the symmetrical fault natin. So wala tayong zero sequence yan. Okay? Wala tayong value or zero yung value. Ng zero sequence saka negative sequence natin. Okay? Next. Next problem is 51. Okay, a certain wire resistance R, another wire of same material has half length and half diameter. Okay, the resistance of the second wire is blank. Okay, so meron daw tayong original wire. Ito na lang nun. Okay, so for this particular wire, we have a resistance R1, which is just equals to R. Okay, para yung sinabi ko sa problem, yung first resistance natin o yung original resistance natin is represented by R. Okay, so meron tayong original length L1 and meron din tayong diameter. Okay, so take note, no? So meron daw tayong same material wire which is half length and half diameter. Okay, so R2 naman to. R2 is kalahati daw ng original length, 1 of L1. Okay, where while yung ating D2 naman, sir, is just equals to 1 of D1 din. Okay? So ngayon, no, so dito sa problem natin, okay, since same yung material na ginamit, therefore the specific resistance rho 1 and yung specific resistance ng pangalawang wire natin equal lang. Okay? So rho 1 just equals to rho. Okay? Resistance formula, R is just equals to rho L all over L. Okay? Therefore rho is just equals to resistance times the area all over length. Okay? Resistance times pi all over 4, yung area formula natin, no? D square all over L. Okay? Ngayon, i-equate natin yung dalawang rho. Okay? So, for rho 1, it is actually R1 o R, okay, times pi all over 4, D1 square. All over L1 is just equals to rho 2. But my rho 2 is just equals to R2 times yung area ko, pi all over 4 D2. But my D2 here is kalahati na lang daw ng D1. All over L2. But our L2 is 1 half L1. Okay, so magka-cancel yung pi all over 4. Okay, yung L1, yung D1 magka-cancel. Kaya ang matitira dito is actually R1 is just equals to 1 half square is 1/4 divided by 1 half is equals to 1 half. Okay, so 1 half R2. Okay, then R2 is just equals to 2R. Okay, so ang tamang sagot, so 2R1, so letter D, no? Which is equals to 2R. Kasi nga represented yung ating original resistance as R, 2R. Okay, so letter D. Okay, yun yung problem number 51 natin. Okay, so next. Okay, so problem number 52, lumabas ng September 2015. What is the minimum ampacity of a branch circuit conductor for a hermetic motor whose full load current is 20 amps? Okay, so for a branch circuit conductor, so the current ampacity ng ating branch circuit conductor. Okay, so pag sinabing branch circuit, ang minimum kasi nito is 125%. Okay, nung ating full load current ng ating hermetic motor. Okay, so tatandaan kapag branch circuit yung tinatanong dito, okay, ang multiplier na gagamitin natin is 125%. Okay, therefore the branch circuit current natin, okay, is just equals to 125% multiplied by the full load current ng motor natin o hermetic motor natin which is 20 amp. Okay, so tamang sagot 25 amp. Okay, so letters. Okay, so kapag ang tinanong sa inyo, no, so additional lang, okay, is yung current na disconnecting means natin. Disconnecting means. Okay, ang gagamitin naman nating multiplier dito, sir, is yung okay, 115% ng full load current natin ng hermetic. Okay, so tatandaan nyo maigi, no? Kapag ka branch circuit, 125%. Okay, kapag naman disconnecting means, sir, 150. Okay, so tamang sagot is letters. Okay, question? Sige, may kokopya ba dito? Hindi na bumalik. Okay, so next problem. Problem number 53. Okay, problem number 53 sabi, a sinusoidal voltage V of t, okay, has an RMS value of 100 volts. What is the maximum value? Okay, so our maximum value, Vm, is just equals to the square root of 2 ng RMS natin. Okay, therefore, it is just equals to the square root of 2 multiplied by 100. Okay, so tamang sagot, 141 volts or approximately 141. Okay, so pag na-round off natin to nearest integer. Okay, so letter D. Okay, so question dito. Okay, so next. Okay. Okay, so next is question number 52. Okay, so lumabas ng April 2016, two capacitors C1 and C2 are connected in series. Find the equivalent capacitance. Sir, equivalent capacitance 1 all over Cp is just equals to 1 all over C1 which is 50 plus 1 all over C2 which is 30. Okay, therefore the total capacitance is just equals to 18.75 microfarad. Okay, so letter. Okay, yun yung problem number 54 na. Okay. Next. Okay, next question. Okay. So for an ohmic substance, the resistivity is the proportionality constant of, okay, so letter D, no, current density, okay, and electric. Okay, so letter. Okay, ayun yung problem number 55. Okay. So next question, problem 52. Okay, problem number 56 sabi, if the field of the synchronous motor is under-excited, the power factor will be, sir, pag under-excited yung motor, power factor natin is lagging. Okay, so letter E. Kapag naman leading, sir, it is actually over-excited. Kapag unity, no, so normally excited. Okay? So since they're excited yung tanong, okay, laging power factor. Okay, so letter 2. Okay, so next. Okay, next problem is problem number 56. Okay, so lumabas ng September 2016. How many 240 volts, 20 amp branch circuit are required to supply? Okay, so total supply na yung sinabi dito, no? To supply a 60,000 kVA load. Okay, so number of branch circuit conductor, BC, is just equals to the total load, which is 60,000 volt ampere divided by, okay, so wala na kayong multiplier na ginamit kasi nga total load na to. Okay, so 240 volt times 20. Okay, so ang lalabas dito is 12.5, which is approximately 30. Okay, so tamang sagot. Okay, so letter A. Okay, question dito. Okay, so 60 divided by 240 times 20. Okay, so next. Okay, problem 58. Okay, a student kept her 60 watt, 120 volt study lamp turned on from 2 p.m. to 2 a.m. How many columns of charge went through it? Okay, so para mahanap niyo yung charge, hanapin niyo muna yung kuryente. Okay, so given that power is just current multiplied by the voltage, our current is just power, which is 60 watts, all over voltage, which is 120 volts. Okay, so 0.5 ampere. Okay, so by definition, our charge is actually our current times time. Okay, charge in coulomb, okay, current in ampere, and time in second. Okay, sir, may binigay na tayong current, ang nawawala na lang time. Okay, considering nag-aral daw siya ng 2 p.m. to 2 a.m. Okay, so from 2 p.m. to 2 a.m., ilang seconds yung lumipas? Okay, syempre 12 hours yan, obviously. And 12 hours, no, convert lang natin into second. Kasi ang nire-require ng formula natin, dapat yung time is in seconds. So 12 hours is 3,600 second per 1 hour. Okay, therefore, time is 12 times 3,600. Okay, kaya our Q, which is yung charge in coulomb, should be equal to current. Sir, current ko is 0.5 ampere multiplied by time. But my time is 3,000, oh sorry. So 12 times 3,600 second. Okay, which is just equals to 21,600 coulomb. Okay, so letter. Okay, so letter B. Okay. So next, problem 59. Okay, sige, kopya muna. Okay, so next problem is problem number 59. So PEC rin siya, no? So problem 59, so ito yan. Okay, so lumabas nung September 2013. What is the minimum clearance between the recessed incandescent fixture and the nearest point of the storage space closet? Okay, objective type, no, from Philippine Electrical Code, so letter B. Okay, so 150 M. Okay, so letter. Okay, so next. Okay, next question. Lumabas ng September 2021. An unconventional conductor consists of 3 strands arranged vertically. Find the GMR in terms of radius R for an individual strand. Okay? So meron daw tayong unconventional conductors, 3 strands. So 1, okay, 2, and 3. Okay? So in terms of GMR, no, the geometric mean radius formula is just equals to n square o n root square, okay, times the distance combination natin. D1, D2, kung ilan man yan, no? Up to dn square. Okay? So, dn pala. Okay, so times, unahin na lang pala natin, sorry. Meron pa tayong multiplier eh. E raised to negative 1/4. Okay? Multiplied by r raised to n. Okay? So, in terms of radius, naka-multiply siya sa r. Tapos yung distance combination natin. D1, D2. Okay? So dito, since tatlo yung conductors natin, okay? So with respect to their corresponding centers, okay? The distance of 1, 2, and 3. Okay? So from 1 to 2, the distance nito is 2r. Okay? So from 2 to 3, 2r. And from 1 to 3, it is actually 4. Okay, so D12 is 2R, which is also equal to D21. Okay, so yung ating D23, which is actually equal to 2R, is just equals to D32. Okay, and yung D13 natin, which is just equals to 4R, is just equals to D31. Okay, kaya pag kinumpute natin yung GMR dito, our geometric mean radius is just equals to, so n square root nung ating number of conductors, or tatlo, 3 square. Okay, so e raised to negative 1/4 times r raised to n. Okay, multiplied by yung lahat ng possible distance combination, D12 and D21, so 2r. Okay, so dalawa yan, isa, dalawa. So 2r times 2r is 2r. Okay, while D23 naman and D32 is just also 2r and another 2r. So instead na isulat ko pa yung ating r, 2r, square ko na lang. Okay, and last but not the least, yung combination distance ng D13 and D31, which is actually 4r and another 4r for D3. Okay. So pag sinolve natin yan, our GMR, okay, in terms of r is equals to 1.704. Okay, so letter. Okay, so for this problem, tatandaan nyo, okay, so lumalabas ng actual board exam to, no? So kapag ang binigay is either, no, nakatayo, tatlo sila, okay, vertically arranged, or horizontally horizontally arranged with respect to R, ito yung GMR. Okay, pero ang tatandaan nyo rin sa board exam, okay, itong 1.704 na to, lagi nasa choices to. Okay, so ibig sabihin nun, kahit na may ganyang number o ganyang GMR value, kailangan yung drawing natin o yung tinatanong sa problem is nakatayo or nakahiga. Okay, kapag triangularly arranged, diamond, etc., hindi na ito yung tamang sagot doon. Okay, so hindi na ito yun. Kaya wag yung basta-basta lulukswamin tong tanong na to. Okay, so tatandaan nyo yung 1.704 na yan kapag vertically or horizontally arranged yung conductor, which is 3 pins. Ngayon kung triangular or diamond, pero nakita nyo pa rin tong choice na to, huwag nyo nang pipiliin yun. Kasi nga, hindi yun yung tamang sagot. Okay, so for vertical and horizontal arrangement lang. Okay, so letter C, 1.70. Okay. Okay, next problem, the terminal potential difference of a battery is less than its EMF. Okay, so letter C. No? So only when the battery is being discharged. Okay, so letter, pag sinabi natin battery is being discharged, connected siya sa load. No? So kapag connected sa load yung battery, less than yung ating terminal voltage, which is the potential difference ng battery to its corresponding EMF. No? Yung ating electromagnetic force dun sa ating battery. Okay, so next. Okay, next question is problem number 62. Okay, a galvanometer has an internal resistance of 12 ohms and requires 0.1 ampere for full-scale deflection. Okay, to convert the voltmeter reading to 3 volts full scale, one must use a series resistance of Planck. Okay, with respect to galvanometer circuit, okay, so para ma-extend natin yung range ng galvanometer natin, okay, nagko-connect lang tayo ng, so ito yung load natin, Okay, so in terms of galvanometer, nagko-connect lang tayo ng series resistance with respect to the galvanometer natin. Okay, ngayon, no, so may full-scale deflection current kayo dito, IFST. And meron din kayong voltage full-scale deflection dito. Okay, so para ma-compute natin to, actually ohms lang siya. Okay, the full-scale deflection current is just equals to voltage full-scale deflection all over the total resistance, which is actually the series combination ng ating resistance in series and galvanometer resistance is small letter r. Okay, so RSE plus small letter r, which is actually the galvanometer resistance. Okay, sir, ano yung IFSD natin? 0.01 ampere. Voltage full scale deflection is 3 volt. Okay, RSE, which is yung hinahanap sa problem, plus our internal resistance, no, which is 12 ohm. Okay, so pag kinumpute natin yan, our series, okay, resistance that must be connected, okay, is equals to 288 ohm. Okay, so letter. Okay, so ganyan lang mag-solve ng galvanometer. Okay, kung gusto nyo extend yung range ng galvanometer, maglagay lang kayo ng series resistance, no? Para eventually kapag may nag-flow na current doon, okay, yung voltage drop, okay, across the galvanometer maahatol. Okay? So sa series and sa internal resistance, small letter R. Okay? So letter B, 280. Okay? So next question. Okay, question number 63. Okay, so a three-phase, 4-pole, 6/3 induction motor. So binigay yung rotor resistance 0.02, standstill reactance 0.5. Calculate the speed at the maximum torque. Okay? So sabi, no, so max at Tmax, kapag the maximum yung torque natin, meron tayong binabantayan dito condition. Magkakaroon lang kayo ng maximum torque if the slip natin is just the ratio nung ating rotor resistance per phase all over the block rotor reactance per phase natin. Okay? Dito sinabi, okay, yung standstill reactance daw natin per phase, standstill to ST. Standstill is just equal to, okay, 0.5 ohm per phase, of course. Okay? So take note, yung standstill reactance, okay, from the word itself is standstill, no, meaning hindi gumagalaw yung rotor natin. Okay, equal lang din yan sa block rotor reactance natin. Kasi nga, under block rotor condition, sir, our rotor is block or block, no? Hindi siya pinahinahayaang gumalaw. Okay, kaya equal yan. Standstill reactance is equals to the block rotor reactance. Therefore, the slip that corresponds to our maximum torque is just equals to rotor resistance, sir, 0.02, divided by the block rotor reactance na equal sa standstill reactance natin, which is 0.5. Okay, kaya ang tamang slip value natin is 0.04. Okay, ibig sabihin, sir, yung slip to get the maximum torque should be 0.04 or 4%. Okay? So, para makuha natin yung speed ng ating induction motor, which is actually the speed of the rotor, NR is just equals to 1 minus S NS. Okay, but our NS is 120 F. Frequencies are 60 divided by the number of poles, which is 2. Okay, so 1,800 RPM. Okay, therefore, our NR or rotor speed natin is 1 minus our slip 0.04. Okay, multiplied by NS, which is 1,800. Kaya ang lalabas sa sagot dito, 1,728 revolution per minute. Okay, so tamang sagot, letter. Okay, so yun yung tamang sagot natin. Okay, so question. Okay, so next question. Okay, so kung walang question, tuloy lang tayo. Okay, question number 65. Okay, the electromagnetic torque developed by the motor is 150 Newton. If flux is decreased by 20 and armature current is increased by 15%, find the new electromagnetic torque. Okay, so kapag same motor, okay, binabago lang natin yung mga field values, okay, or yung mga parameters natin, okay, pwede natin gamitin yung torque formula dito. Torque, okay, is just a certain constant, okay, si Tikoy, flux IA. Okay, si Tikoy. Okay, so dalawa yung condition dito, condition 1 and condition 2. Okay, at condition 1, our torque 1 is just equals to 150 Newton. Okay, ang hinahanap is torque 2. Okay, but sabi dito, yung original flux natin, flux 1 is flux 1. Okay, original armature current natin is IA1. Okay, ngayon sinabi sa condition 2, ito yung condition 2 natin, no? Okay, so the field flux, which is flux 2, is decreased by 20%. Pag sinabi natin decreased by 20%, ibig sabihin 80% na lang yung natitira, which is 0.8 ng flux 1, decreased by 20. Okay, in terms of the current 2 naman, o armature current 2, okay, the armature current is increased by 15%. Okay, so pag sinabi natin nag-increase ng 15%, 1.15 ng armature current 1 or original armature current. Okay, so given this, ratio and proportion lang natin, T2 all over T1 is just equals to K flux 2 I2 IA2 all over K flux 1 I2. Okay, torque 2 yung unknown, T2 is just equals to T1. Sir, T1 ko 150. Okay, so cancel lang yung K. Sir, flux 2 ko kasi sir is 0.8 ng original flux times IA2 which is actually 1.50 naman ng original armature current. All over the original flux times the original armature current. Okay, so cancel, 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 cancel. Therefore, our T2 is just equal to 138 Newton meter. Okay, so letter E. Okay, so letter E. No? So question. Okay, so ganyan lang mag-solve niya, no? So torque formula lang. Okay? So torque is a certain constant K. So galing kay Sophia formula yon. K, I. Okay, so letter A. No? So letter A. Yeah. Okay, next. Okay, next question, problem number 65. 87 is a device function. Okay, so based the ANSI device number of what relay? No? So differential relay. Okay, so letter E. Yan yung number 87. Okay. So next, problem number 66. Okay, problem number 66 sinabi, the magnetic field distance, the magnetic field a distance of 2 cm from a long straight current carrying conductor is 2.0 times 10 raised to negative 5 Tesla. Okay, the current in wire is flat. Okay, so dito since sinabi, a long straight current carrying wire, no, meaning mahaba or infinite yung distance nila, no? Okay, direct formula natin, our magnetic flux density is just equals to mu sub 0 I all over 2 pi. Okay, where our beta is the magnetic flux density measured in Tesla. Mu sub 0 is the MKS unit ng permeability of free space. Okay, ito naman sir, current in ampere, while yung D natin dito should be in meter. Okay, sir, yung D na binigay, which is the distance ng ating magnetic field to the conductor is 2 cm. Okay, convert nyo lang yan papuntang meter. So, 100 cm per 1 meter. Okay, ang lalabas dito is 0.02 meter. Okay, therefore, our current is just equals to beta times 2 pi D times mu sub 0. Okay, beta. Sir, beta ko, 2 times 10 raised to negative 5. Okay, so times 2 pi times 0.02 all over our mu sub 0, which is 4 pi times 10 raised to negative 7. Okay, so pag kinumpute niya, nang lalabas, 2 ampere. Okay, 2 ampere, so letter C. Okay, so yun yung problem number 66. Okay, so next. Okay, sige, kopya muna. Okay, next problem is problem 67. Okay, problem number 67, 1 Weber is same as flux. Okay, so according kay Faraday's law, the EMF induced is just equals to flux or number of turns, ng flux per unit time. Okay, so sabihin lang natin 1 turn, no? So per 1 turn. Okay, so our EMF induced, which is in volts yan is just equals to 1 turn multiplied by flux. Sir, ano bang unit ng flux natin? Flux is in Weber, while yung time natin is in second. Okay, therefore, pwede ko sabihin that 1 volt second is just equals to 1 Weber. Okay, so minultiply ko lang yung S ko. Okay, kaya ang tamang sagot dito, 1 volt second is 1 Weber. So letter E. Okay, so letter A yan. Okay, so question. Next. Okay, problem 68. Okay, problem number 68, lumabas ng September 2017, bumalik ng September 29. Okay, So a washing machine in effect is an RL circuit if machine takes 311 watts at 4.5 ampere from 155 volt source when operating normally, find its power factor. Okay? So this problem, okay, so ang hinahanap is power factor. Okay, so based sa power triangle natin, P, Q, and S, okay, our power factor is just equals to the ratio ng P and S natin. Okay, so meron na tayong P. Ang P natin, sir, is 311. Okay, while our S naman can be computed as current multiplied by the voltage. No, yung magnitude lang ng ating apparent power. Okay, so dito binanggit yung current. Our current is 4.5 ampere. While yung voltage naman natin is equals to 155. Pero take note, no? So alam naman natin ano ba yung mga standard voltage natin. Okay? So sa US 110, okay, sa atin 220 volts. Okay, in terms of nominal, no? So 115 and 230. Okay? So dito, yung actual voltage talaga dito is not 155. But instead, no, troubleshoot ko no? Yung voltage na gagamitin natin dito, 115 volts lang. Okay? So ngayon, no, so since na-correct na natin or alam na natin yung tamang value ng voltage, compute na natin yung S. Our S is just the current, 4.5, multiplied by the voltage, which is 115. Okay, so pag kinumpute natin yan, 4.5 times 115, okay, it is just equals to 517.5. Okay, volt ampere. Okay, so in terms of power factor, our power factor is P, okay, where P is equals to 311 all over S. Okay, where S is equals to 517.5. Okay, so pag kinuha niyo yan, 0.6 yan, o 0.6 lagging. Sir, bakit lagging? Okay, sir, inductance kasi yung, inductor kasi yung component ng reactive power natin. Okay, therefore, lagging. Okay, so 0.6 lagging. So letter. Okay, so yun yung problem number 68. No? Okay, next. Okay, sige, copy po na. No? So next. Okay, next problem is 69. Okay, peak load plants are designed. Sir, pag sinabing peak load, okay, so gumagana lang sila during peak hours, no? O kung mataas yung demand. Okay, peak load plant is actually low capital, high operating cost, no? So kapag peak load, ano ba yung sample ng peak load plants natin? Okay, mga oil, no? So sila yung huling pinapatakbo no? During peaking kasi nga walang-wala na or minsan masyadong mataas yung demand. Okay, of course, no? In terms of oil-based power plant, okay, so mababa yung capital mo. Of course, no, in comparison to the base load, ha? Okay, pero in terms of operating cost, alam naman natin, mahal yung fuel niyan, high operating cost yan, si peak load. Okay, dalawa yung version ng tanong na to, no? So, una, si peak load plants, okay, low capital, high operating. Okay, so kung ma-encounter nyo sa board exam, yung base load plant naman, okay, high capital pero low operating. Okay, so itong letter B na to, base load plant naman. Okay, so yan yung problem number 69 natin. Okay, ay sorry, A pala, sorry. Yung choice A, low capital, high capital, low operating letter. Tama naman. Okay, so next. Okay, problem number 70. Okay, problem number 70, sabi. Okay, so a series RC circuit is connected to an EMF having an angular frequency of omega. The current is blank. Okay, sir, RC circuit. Okay, so in terms of loading nature, capacitive yan. Okay, kapag daw capacitive yung loading, okay, so paano mo nalaman, sir, na capacitive? Okay, capacitor yung component ng reactive power natin. Capacitive. Ano capacitive? Capacitor. Okay, our current daw, ito yung current natin, ha? I will leads our E. Ibig sabihin, current will leads our EMF or yung voltage natin with a certain angle, theta. Okay, so dito, dalawa na lang pwede natin pagpilian. It's either letter A, where current leads, or letter C, where current leads also. Okay, so yung mga lags dyan, hindi na pwede. Okay, pero kailangan natin hanapin yung theta. Okay, our theta, So based dito sa sa impedance triangle natin is just equals to arctangent ng ating opposite side which is XC all over R. Eh sir, ano bang value ng XC? O X sub C natin is 1 all over omega C. Okay, kaya pag sinubstitute natin yan dito, our theta is arctangent ng 1 all over omega C all over R. Okay, so para ma-simplify natin to, okay, so pwede natin i-multiply yung numerator, yung ibabaw na lang ng 1 all over R. Numerator, i-multiply din natin yung denominator ng 1 all over. No, para 1 lang sila. Okay, so R multiplied by 1 all over R is 1. Okay, therefore, ang matitira dito, our theta is arctangent ng 1, yun 1 times 1, which is 1, all over omega C R. Okay, omega C. Okay, kaya ang tamang sagot, I leads E by arctangent 1 all over omega C R. Kaya ang tamang sagot, letter E. No? So, letter E. Okay, so letter A. So, yun yung problem number 70 natin. Okay, so letter E. Next. Okay, kopya. Okay, so next is problem number 71. Okay, so problem number 71, the area of hysteresis loop is a measurement or measure of, okay, so letter C, energy loss per cycle. Okay, so letter. Okay, so next, 72. Okay, problem number 72, an 8 millihenry inductor and 2 ohm resistor are wired in series to ideal battery. Okay, a switch in the circuit is closed, no? So under initiation circuit ng transient, at which time the current is 0. The current reaches its final half value at time is equals to blank. Okay? So dito, no, so direct formula, kapag ka initiation circuit, no, meaning, okay, drawing na rin natin, no? Okay, so meron tayong circuit and kinonect natin siya. Okay, initiation circuit ang tawag, no? So from the originally unenergized circuit, kinonect natin. Okay? So in terms of current equation, direct formula, our current I or instantaneous current I is just equals to E all over R, quantity 1 minus E raised to negative T R all over. Okay? So since sinabi niya, the current reach its final value, sir, ano ba yung final value natin? Okay? So matatawag natin final yung value natin sa current kapag ka steady state na yung ating condition. Eh sir, kailan ba natin na-reach yung steady state? Okay, ma-reach natin yung steady state, okay, at T is equals to, so kapag nakasaksak na ng matagal yung ating transient circuit, no? So sabihin na lang natin, okay, so para mas mas matagal, no? So sabihin na natin as T approaching infinity. Okay, so matagal na siya nakasaksak. Okay, therefore, the final current is just equals to E all over R 1 minus E raised to negative infinity RL. Okay, infinity multiplied by RL is infinity. E raised to negative infinity is 0. Okay, 1 minus 0 is 1. Therefore, the final current natin is just equals to E all over R. Okay, ibig sabihin sir, no, shorted na yung ating inductor. Okay, at the steady state condition, our inductor will act as a short circuit. Okay, so hindi na siya, no, parang wire na lang siya. Kapag DC yung supply. Okay, so ngayon, ano bang hinahanap? Yung time daw kung saan our current, okay, is kalahati daw ng final. Okay, so our current is just equals to E all over R 1 minus E raised to negative T R. Okay, since ang hinahanap is yung kalahati lang daw yung ating current, so 1/2 ng final, sir, ito yung final ko, E all over R. Therefore, 1/2 ng E all over R is just equals to E all over R multiplied by 1 minus E raised to negative T. Okay, resistance value 2, inductance value is 8 millihenry. Okay, so unknown yung ating time, so magka-cancel yung E all over R. Pag sinolve natin yung time dito, okay, T is equal to 2.8 milliseconds. Okay, so letter. So ganyan lang mag-solve nung problem number 72 na. Okay, so madali lang. Okay? Next. Okay, sige, kopya muna. Okay, next problem is problem number 74. Okay? So for problem number 74, so next na natin. Okay? 73 I mean, a 13.8 kilovolt distribution line has a Thevenin's equivalent impedance of 2.63%. Okay? If a face-to-face fault occurs at B and C, determine the fault current at 10 MVA base. Okay? So take note, no? With respect to the three-phase fault muna, sige, hanapin muna natin yung base current. Our base current is just equals to S base all over square root of 3 V base. Okay, sir, ano ba yung ating S base? Base, MVA daw natin, 10 MVA, which is 10 times 10 raised to 6, all over square root of 3 nung ating voltage base, which is 13.8. Okay, therefore, our base current now is just equals to so 418.37 ampere. Okay, so letter tuloy. So naka-ready na yung base current natin. Okay, so kunin muna natin or hanapin muna natin no, kung ano yung ating phase-to-phase fault source. Okay, so in terms of three-phase fault, the fault current ng three-phase per unit natin is just equals to 1 all over the total Thevenin's equivalent impedance. Okay, therefore, it is just equals to 1 all over. Okay, so 2.63% is just equals to 0.0263. Kapag ka decimal or per unit. Okay, so 0.0263. Okay, so under the assumption no not equal yung ating IA1. Okay, kapag hindi binabanggit kasi i-assume natin na equal to. Okay, so yung direct formula ng phase-to-phase fault natin, okay, and also the phase-to-phase fault per unit natin is just equals to my line-to-line fault. Okay, so phase-to-phase is just equals to the line-to-line. Direct formula is just square root of 3 all over 2 ng three-phase fault natin per unit. Okay, therefore, it is just equals to square root of 3 times 2 multiplied by 1 all over 0.026. Okay, so the fault current phase-to-phase per unit is just equal to, okay, so computin muna natin. Okay, so 32.93 ampere. Per unit pala, sorry. Okay, so para makuha natin yung actual fault current, okay, the actual fault current phase-to-phase is just the per unit current, no, which is 32.93 per unit multiplied by the base current natin, which is actually 418.37. Okay, so ito sir ay the base current I base. Okay, equal to, so 418. Okay, so 13,000. Okay, so rounded off to the nearest 100. 13,800 ampere. Okay, so mapapansin nyo dito, no, so sa choices natin, walang 13.8. Okay, kasi nga, yung choices natin dito is actually, no, may mali. Okay, so of course, no, so kung lumabas na ng actual board exam ko, okay, so ang pipiliin natin dito is actually yung pinakamalapit and yung pinakakamukha. Okay, so kapag walang 13,800 sa choices, pag dumating yung actual board exam nyo, ang pipiliin nyo is yung 13,000. Okay, hindi ko pwedeng sabihin approximately equal, pero ang pipiliin nyo dapat yung kamukha, which is 13,000. Okay, so possible kasi nung tinype yung 8, naging 0. Okay, so letter A. Okay, yun yung problem number 73 na. Okay, so next problem Okay, so wala nang tanong. So next problem, 74. Okay, ulitin ko lang ha. Sa board exam, kapag lumabas yung 13,800 yung pipiliin nyo, okay, pero since sa board exam, no, may mga maling tanong tayo dyan, okay, pipili natin yung pinakamalapit. Okay, so 13,000. Okay, so RA 7832, okay, concerns on, so letter B, no? So filterage of electricity. Okay, so theft of transmission material and rationalizing of system loss. Okay, so letter A, EL loss. Okay, so next problem. Okay, problem number 75. Okay, in an RLC circuit connected to a source E at resonance, then blank. Okay, so during resonance, ito yan, during resonance, our XL is just equals to X. Kapag series resonance, during series resonance equals L. Okay, since equal yung kanilang reactance and series, okay, therefore the voltage across them should also be equal. Kasi nga, so mag-multiply ka lang current sa kanilang dalawa. Okay, IXL is VL, IXC is VC. Okay, so the total voltage is just equals to kapag RLC circuit no series, VR square, yung voltage drop across my resistor, plus yung net voltage across my inductor and capacitor. Okay, since equal sila, no? So, a number minus a number is 0. Okay, so kung equal yung value. Kaya yung voltage natin o yung source voltage V natin, magiging equal lang ngayon sa resistor voltage natin. Okay, so voltage across, okay, o the voltage across R is equal to the applied voltage. So letter B. The voltage across R is just equals to my applied voltage. Okay, so letter B. Okay, so next. Okay, next question is 76. Okay, problem number 76. A delta 3-phase wire, a 4-wire secondary, 230/115 would have a high leg to neutral voltage of blank. Okay, so delta to, so delta 3-phase transformer. Okay, considering balance yung ating transformer, so A, B, and C. Okay, so VAB is just equals to, okay, so 230 angle 0. Okay, so since balance, BBC ko is 230 angle negative 120 and VCA is just equals to 230 angle 120. Okay, ngayon, ang hinahanap is the high leg to neutral voltage. With respect to the high leg, okay, so yun yung A natin. A with respect to the neutral natin, which is actually a center top transformer dun sa phase BC natin. Okay? O sa line BC natin. Okay? So dito, kapag nag-KVL kayo, okay, ito yung hinahanap sa problem. Our VAN is actually the high leg to neutral voltage natin. Okay? So kapag nag-KVL kayo dito, our VAN is just equals to VAB, okay, plus VBN. Okay, so ito neutral din. Okay, but take note yung voltage VBN natin, so parang auto transformer lang siya, no? So mapapansin nyo kalahati, no? Kalahati ng voltage ng ating BBC. Okay? So VAN is just equal to VAB plus VBC all over. Okay, therefore our VAN is just equals to VAB. Okay, our AB is 230 angle 0 plus VBC which is 230 angle negative 120 divided by 2. Okay, take note ito, okay, kasi nga center top, no? So yung VBN natin, okay, so kinalahati niya lang yung number o yung winding ng ating VBC. So therefore, kalahating voltage lang din. Okay, so pag sinunod nyo, VAN, which is the high leg to neutral voltage, kaya mako-compute natin dito. So move to 230 plus okay, so 199 angle 30. Okay, syempre, ang kukunin nyo lang yung magnitude. Okay, magnitude niyan is letter. Okay, so tatandaan nyo, okay, sa board exam, okay, so pag may napansin kayong ganitong tanong, huwag nyo rin lulok sa paminal. Okay? Kasi minsan, ang binibigay dyan, hindi 230/115. Okay, minsan, 220/110, o di kaya naman, may nabasa rin ako, 440 ata/220. Okay? So kung gusto nyo tandaan yung tamang sagot, tatandaan nyo dapat for 230/115 volts lang. Okay? So tatandaan yung maigi. Okay, next. Okay, next question is 77. Okay, a 3.5 millihenry inductor and 4.5 millihenry inductor are connected in series. Okay? And a time varying current is established in them. What is the total EMF of the combination? When the total EMF is 16 volts, the EMF of the larger conductor is blank. Okay? So dito, source. Okay, so meron tayong inductor. Okay, so sinabi niya kasi, and a time varying current is established between you. Okay? So pwede nating i-assume na AC to. Okay, nagbabago-bago kasi yung ating voltage. Okay? So dito, since sinabi niya L1 is 4.5 millihenry and L2 is equals to 3.5 millihenry conductor. Okay, so nang hinahanap, if the total EMF is 16 volts, ang hinahanap is voltage across the larger inductor, which is V1. Okay, so dito, no, since inductor in terms of the total inductance is parang resistance lang, so pwede natin ding gamitin yung idea behind voltage divider theorem. Okay, so V1, okay, is just equals to the total voltage L1 plus L2. Sir, total voltage is 16. Okay, L1 ko is 4.5. All over L1, 4.5 plus 3.5. Okay, so ang tamang sagot dito is letter B, 9 volts. Okay, so letter B. Okay, next question. Okay, so question number 78. Okay, so dito oscillation frequency. Okay, our oscillation frequency F sub 0 under normal condition equal lang yan sa resonance frequency natin. Formula 2 pi square root of L. Okay, ngayon sinabi sa problem, okay, so babawasan natin yung oscillation frequency. Pag babawasan, okay, kailangan mo pababa natin yung value. Okay, so mapapababa lang natin yung F of 0 natin o F sub 0 which is the oscillation frequency kung tataasan natin both L and C. Okay, so ano ba yung maximum ng L? So binanggit, the maximum value of L is 2L and the maximum of value of C is 2C. Okay, therefore, kailangan natin gamitin yung maximum value ng L and C para magkaroon kayo ng minimum value dito sa oscillation frequency. Okay? Kaya ang tamang sagot, gagamit kayo dapat ng 2L and 2C. Okay? So letter. Okay? So next. Okay, next question is question number 79. Okay, for this question, in a three-phase 6-pole induction motor, the space angle between two consecutive phases is blank. Okay? So dito, so under a three-phase waveform, okay? So meron tayong three-phase sinusoidal wave, isa, dalawa. Okay, so pagtsagaan nyo na lang drawing ko, no? Okay? So for a 360-degree electrical, okay, so paghahati-hatiin na lang tatlo yan. Okay, therefore, the electrical degree per phase natin, electrical degree per phase is just equals to 360 divided by 3 phase to, so 3. Okay, therefore, each covers 120-degree electrical. Okay, ayan yung electrical degree ng ating, per phase ng ating 3-phase waveform. Okay, pero kung mapapansin nyo dito sa choices, hindi naman electrical degree yung hinahanap. Okay, yung corresponding mechanical degree ng ating per phase. Okay, sir, ano ba yung conversion? Okay, conversion, the electrical degree per mechanical degree is just equals to the number of poles divided by 2. Okay, ngayon, yung per phase electrical equivalent is 120 electrical degree. So 120 divided by the mechanical equivalent, okay, theta, where P is equals to 6 and all over. Therefore, theta M is just equals to 120 divided by 3, which is 40 degrees. Okay, so 40 degrees, so letter D. Okay, yun yung problem number 79 natin. Okay, so next problem is problem number 80. Okay, problem number 80, an LC circuit has a capacitance of 30 microfarad and inductance of 15 millihenry. At time is equals to 0, the charge on the capacitor is 10 microfarad and the current is 20 milliampere. What is the maximum current? Okay, so ang ipagsusolve pa rin natin, law of conservation of energy. Okay, the work done ng inductor at capacitor should be constant. Okay, so WL1 plus WC1 should be equal to WL2 plus WC. Okay, so at time is equals to 0. Dito naman, sir, at time is equals to T, where our current is maximum. Okay, sir, ano bang formula natin dito? Okay, formula natin is 1/2 L. Okay, so ano ba yung value ng L natin? Our L is yung inductance natin ng 15 millihenry. Sulat na lang muna natin. No? So 1/2 Li square plus 1/2 Q square all over. It's just equals to 1/2 Li square plus 1/2 Q square. Okay, so at time is equals to 0, our current now is 20 milliamp. Okay, so 1/2 inductance 15 millihenry times our current, which is 20 milliamp. Plus 1/2, sir, yung Q. Okay, our Q is, ano ba yung Q ko dito? Charge, no? So, which is 10 microcoulomb. Square all over our capacitance, which is 30 microfarad. Just equals to 1/2, okay, inductance natin, 15 millihenry again. Okay, pero tatandaan natin, para magkaroon kayo ng maximum current, dapat maximum din yung stored energy sa inductor, therefore 0 dapat. Okay, para maging maximum yung stored energy natin. Okay, kaya ito ay nakamultiply sa I. Okay, so pag kinumpute nyo yung I dito, I is just equals to 25 milliampere. Okay, so ang tamang sagot, letter C. Okay, so 25 milliampere. Basta tatandaan nyo, kapag pinaparap yung maximum current, dapat lahat ng energy nyo naka inductor. Therefore, walang energy stored sa capacitor. Kapag maximum charge naman yung hinahanap, wala dapat energy stored sa inductor. Lahat naka capacitor. Okay, so ganun yun ang sasabi. Okay, so dito 25 milliampere, so letter C. Okay, so next problem, problem 81. So lumabas noong September 2019. So sabi, the effect of electric shock in the human body, okay, will be depend on, okay, so tamang sagot, letter C. No? So yung actual current flowing in the body. Okay, so letter C. Okay, so next. Problem number 82. Okay, 3 equal impedance connected in Y. So equal daw yan, JY is equals to 4 minus J7. Okay, find the equivalent impedance in delta. Okay, Z delta is JY or 3JY, which is just 3 multiplied by 4 minus J7. So 12 minus J20. Okay, so letter. Okay, so letter B. Okay, so problem number 21 is left. Okay, so quick break lang, no? So water break. Okay, so break muna sa okay, 5 minutes. Okay, so rinig naman ako, no? Hello? Hello, hello? Rinig na ako ulit.
Yes, sir.
Yes, sir.
Rinig niyo ba ako? Hello?
Yes, sir.
Okay, sige, wait lang, may tumatawag. Okay, so next problem, tuloy lang natin. Okay, so which of the following factors does the magnitude of the fault current depends on? Okay, so tamang sagot. Okay, so letter C, both A and B. Okay, so both the total impedance on the fault point and the voltage across the fault point is okay, effects or factors in determining the fault current. Okay, so letter C. Okay, so next, problem number okay, 84. Okay, problem number 84. Okay, so how many two-wire 120 volt 15 ampere branch circuit are required to supply a show window that is 30 feet long and continuously lighted? Okay, so dito, no, so according kay PEC, okay, so it requires us, okay, for a show window, okay, it requires one receptacle per, okay, 12 inch of 12 inches lang. Okay? So dito, so each receptacle, no, so having a branch circuit, having the total volt ampere which is equals to 180 volt ampere. Okay? So ngayon, no, so para mahanap natin yung number of branch circuit natin, hanapin muna natin yung total kVA. Okay? So total kVA of volt ampere is just 120 multiplied by 15 ampere. Okay? So which is just equals to, okay, so 120 times 15, so 1,800 volt ampere. Okay? So sabi, no, so per 1,800 volt ampere, okay? So kada receptacle daw meron tayong one receptacle per 12 inch. Okay? So for 30 feet, convert nyo lang yan sa, okay, 12 inches per feet. Okay, so 30 times 12 is 360 inches. Okay, so para malaman natin yung total kVA na kailangan, volt ampere na kailangan natin, okay? Therefore, i-multiply lang natin, no? So, 180 volt ampere times, okay, 12 inches. Sorry. So, 180, okay? So, per 12 inches, multiplied by 360. Okay, so ilan to? So 180 times 360. Okay, divide by 12. Okay, so 5,400. Oh, Okay, so 5,400. Okay, yung tamang sagot dito is 1,000. Okay, so 1,800. Okay, so wait. Wait lang. Submit lang. Okay, so 5,400 volt pump. Okay, so dito, ngayon ko lang muna. Okay, so 1,800. Okay, so per receptacle, meron daw tayong 180 volt amp. Okay, so 180 volt ampere. Okay, so ilang receptacle ba yung kailangan natin? Okay, so dito, so yung total volt ampere natin, i-multiply lang natin ng 1.25. Okay, it is just equals to, okay, so 1,800 times 1.25. Okay, 2,000 okay, volt ampere. So times, okay, so per receptacle o per branch circuit, branch circuit, 180 volt amp. Okay. So 30. So ilan ba to? 30 foot long. Okay, so 2,250 volt ampere. Okay, then sinabi dito 180 volt ampere. So ilan ba yung ano natin? 12 inches. Times 2,250, 30 all over. Hmm. 120. Okay, so wait lang class, wait lang. Confirm ko lang.
Walang sound, sir.
Okay? So dito, so banggitin ko lang ulit, okay, per 12 feet, okay, it requires us to have okay, one receptacle of 180 volt ampere. Okay, so dito, 180 volt ampere. So 30 um, volt ampere per 12 inches times yung 30 natin. So ilan to? Okay, therefore 180 times 30 divided by 2 is 450. Okay, ngayon dito, yung total natin, okay, total VA is 2,250. Okay, per receptacle natin is 450. So ang lalabas sa sagot dito, okay? So 2,250 divided by 450 is 5 receptacle. Okay? So letter, so yan lang nung, okay? So letter D, so 5 receptacle. Okay, so magagamit lang kayo yung total volt ampere natin nung per branch circuit natin is 1,800 times 1.25. Okay, yung load factor, ay yung factor na ginamit. Okay? Therefore, the number of branch circuit, okay, so ano to number of branch circuit is the total load, okay, all over yung receptacle volt ampere. Okay, which is, okay, 450, so 5. Okay, kaya ang tamang sagot, letter. Okay, so next. The next question is problem number 85. Okay, the armature current of a permanent DC motor is 0.8. At no load, the motor draws 1.5 amp. Okay, supply voltage 25 volts. Okay, and runs at 1,500 RPM. Okay, so anong hinahanap sa problem? Okay, the efficiency, hinahanap efficiency ng motor when operating at full load at 1,500 RPM. Okay, so na-record ko ba? Check ko lang muna, baka hindi ko na-record. Okay, so nakaka-record naman. Okay, so dito, so may binigay, so drawing lang muna natin. So meron daw tayong DC motor. Okay, so ito yung R, ito naman yung ating EB. Okay, so may terminal voltage tayo, VT, may armature resistance, RA, may line current tayo, IL, which is actually in series with my armature current. Okay, IL is just equals to I. Okay, so in terms of KVL natin dito, the terminal voltage is just equals to IARA plus EB. Therefore, EB is just equals to BT minus IAR. Okay, so may binanggit kasing condition, sir. No? So binanggit niya, at no load. Okay, so at no load, okay, in terms of power flow, ito yung power flow natin. The power developed is just equals to the stray power loss or SPL plus the output. Okay, kapag no load tayo, yung output natin 0. Okay, therefore, the power developed is just equals to my stray power loss. Okay, ibig sabihin, at no load, sir, the power developed is just equals to the stray power loss. Okay, sir, ano ba formula ng power developed natin? Power developed is EB. Okay, so EBIA. Okay, syempre at no load, therefore IA no load, EB no load. Okay, sir, ano bang formula ng EB? Our EB is just VT minus, okay, so yung ating IA no load, sir, IA no load natin is 1.5 ampere. Okay, so VT IA RA multiplied by IA no load. Okay, terminal voltage 25 minus IA no load 1.5 times 0.8 multiplied by 1.8, 1.5 I mean is equals to SPL. Kaya pag kinumpute natin yung stray power loss na yan, okay, so our stray power loss is equals to okay, so 35.7. Okay, watts. Okay, ngayon, at full load, dito na tayo. Dito tayo magko-compute ng efficiency. Sir, efficiency formula is just equals to output all over input. Okay, but our output is actually my input minus all the losses. Okay, all over the input. And losses natin sa DC motor is just the stray power loss. Okay, SPL minus PC. Okay, all over the input. Sir, input power natin is input. Iharapin muna natin. Okay, so input power natin is just equals to VTIN. Okay, in terms of the input side, okay, ito yung input natin, no? Okay, ito yung buong input natin. Okay, which is actually VTIL. Sir, terminal voltage natin, 25 multiplied by IL. Okay, our IL is at full load, no, syempre, is 3.5. Okay, therefore, the input power is 25 times 3.5. Okay, so magiging sagot natin dito, o yung input power natin, okay, so is 87.5 volts. Watts, sorry. Okay, with respect naman sa PCU natin, the copper loss natin dito, isa lang naman yung copper loss natin, which is the losses across the armature resistance, no? So IA square RA. Okay, but our IA is just equals to my line current, no? Kasi nga in series sila. Okay, line current 3.5. Okay, at full load tayo nagko-compute ng efficiency, no? Times 0.8. Okay, therefore, ang sagot natin, 3.5 squared times 98, 9.8 watts. Okay, kapag nag-compute na kayo ng efficiency, input which is 87.5 minus stray power loss 35.7 minus the PCU which is 9.8 all over 87.5. Okay, so therefore efficiency is 0.48 or 48%, no? Kapag binultiply niyo ng 100%. Okay, so tamang sagot letter. Okay, so letter A. So yan yung problem number 85. Okay, okay, kopya. Okay, so next, 86. Okay, solar cells for power generation entail the major disadvantage. So tamang sagot, okay, medyo mahal daw. Okay, so letter B. Okay, so letter B. So next. The next problem, okay, pinapahanap is mutual inductance. Direct formula. Mutual inductance is A, coefficient of coupling L1, L2. Okay, so binanggit coefficient of coupling is 0.5. Square root of L1 and L2. Which is just equals to 6 millihenry. Okay, so letter C. Okay, so next problem, problem number, A88. A DC motor driving an electric train faces a constant power load. Okay, if it is running at rated speed and rated voltage, if the speed has to be brought 0.25 per unit, the supply voltage has to be approximately brought down to blank. Okay, so dito, so sinabi sa problem, constant power. Ibig sabihin, kahit bumaba yung speed, bumaba yung voltage, bumaba yung kuryente, dapat ma-maintain mo pa rin yung constant power mo. Okay? Sir, power is just equals to IV. Okay? In terms of torque, no? So 2 pi nt naman siya. Okay? And in terms of omega, it is just equals to 2 pi n is omega t. Okay? So with respect to the torque formula natin, torque is just equals to K flux IV. Flux I. Okay? Kapag daw series yung motor, okay, our flux, according to Ampere's law, no, is directly proportional to current. Okay? Therefore, pwede ko sabihin that our torque T is just equals to K I squared. Okay? So ngayon, papalitan lang natin yung T na to, nitong value na to, okay, panibagong power formula. It is a constant, omega multiplied by a certain constant K I squared. Okay, ito yung power formula na gagamitin natin. Okay, ngayon, dalawa yung condition. Okay, condition 1 sinabi. Okay, so P1 must be equals to P2. Constant power yan, ha? Okay, ano bang formula ng P1? P1, ito muna yung formula na gagamitin nyo, is omega 1 K1 I1, which is just equals to omega 2 K2 I2. Of course, K is constant, no? Magka-cancel lang siya. Okay, so dito sinabi sa problem, if the speed is to be brought down by 25 per unit, okay, from the original speed omega 1, bababaan daw natin yung speed up to 0.25, okay? Therefore, omega 2 is 0.25 ng original speed, which is omega 1. Okay, ito yung 0.25 per unit na tinatawag. No? Okay, so omega 1 is just, I1 is just equals to omega 2. But omega 2 is 0.25, omega 1, I1, o I2 squared. Okay? So, but I2, okay, syempre, no? So, kung mapapansin nyo, since kailangan ko ma-maintain yung constant power, okay, since bumaba yung speed ko dito, dapat yung current I2 ko tataas, okay, para ma-maintain ko yung constant power. Okay? So, yung I2 ko dito, para ma-maintain ko yung balance, should be equal to 2I1. Okay? Bakit? Okay? So, pag sinubstitute ko 2I1, Okay, so ano mangyayari? Okay, 0.25 times 2 square, which is 4, is just equals to 1. Kaya magiging resulting answer pa rin yan, omega 1 I1 square is just equals to omega 1 I1 square, which is just equals to P1. Okay, therefore, kailangan kong, okay, at okay, omega 2, which is 0.25 omega 1, kailangan kong tasan yung current ko ng doble. Okay, 2I1. Just to maintain the constant power. Okay, so ngayon, sa formula ng power natin, okay, which is P1 V1, P1 is just equals to V1, I1 V1. Okay, so ano yung I1 ko? Okay, my I1 is just equals to I1. V1 is V1, must be equals to I2. Okay, but our I2 based dito, okay, should be equal to 2I1. Okay, if we brought down the speed to 0.25 per unit. Ngayon, to maintain the balance, okay, kailangan bawasan ko naman yung voltage. Okay, so para maging constant yung power ko. So voltage ko should be V1 all over 2. Kasi magka-cancel to. Okay, so pag nag-cancel yan, ang matitira, I1 V1 is just equals to I1 V1. Which is actually constant power. P1 is just equals to 2. Okay, since ang kailangang value ng voltage to ko is V1 all over 2, okay, which is just equals to 1 of V1, which is just equals to 0.5 per unit. No? So 1 up is 0.5. Okay, so multiplied by V1, which is actually my okay, base voltage. No? So tamang sagot dito is 0.5 per unit. Okay, letter B. Okay, so letter B. No? So problem number 89. Okay, next problem. Sorry, i-copy muna kayo. No? Kopya muna. Okay? Tapusin nyo na yung kopya mo. Okay? So tuloy lang natin. Okay? So problem number 90. Okay? 89 I mean. In aluminum conductors, steel core is provided to increase its tensile strength. Okay? So letter B. Okay? So next. 90. Okay? So EMF generated by generator, ito pa rin yung formula. PZ flux all over 60. Okay? So hanapin muna natin yung parallel paths. Parallel paths since wave siya. Wave simplex. 2M. 2 times 1 kasi simplex. Therefore, A is equals to. Okay, ngayon, in terms of the total conductors, okay, so total conductor Z, okay, so per one conductor, so conversion muna, no? So one turn, for a single turn ng coil natin, okay, it is actually equal to 2 conductors. Okay, so sinabi sa problem kasi, okay, so the total turns muna, no? It's just equals to, okay, so 32 coils times, okay, so 6 turns per coil daw. Okay, so magka-cancel yung coil. Ang number of turns natin is 190. Okay, so para makuha niya yung total conductors, see, total conductors is the total number of turns, which is 92 turns. Convert nyo to conductor. No? So, one turn, kailangan mo ng dalawang conductor. Kaya lalabas is 384 conductors. Okay, so dito, no, so para ang formula natin, okay, so in getting Z, okay, our E is the number of poles P, which is 8. Okay, conductors 384, flux in Weber 0.06, number of turns speed natin is 250, I mean, all over 60 times parallel patch, which is 2. Okay, pag sinulog mo yan, ang lalabas, 384 points. Okay, so letter. Okay, so letters. Okay, so yan yung problem number 9. Okay, so problem number 90, 384 points. Okay, so question dito. Okay, next, 91. Okay, problem number 91, on a three-phase balance delta load supplies 240 VAC, the wattmeter readings are negative 1710 and 3210. What is the current? Okay, so in terms of current, okay, so dito natin siya kukunin. The total apparent power is square root of 3 ILB. Since ang hinahanap is current, line current. Our IL is just equals to total apparent power square root of 3 VL. Okay, so in terms of the apparent power, okay, so yung ating power triangle, okay, ito sir ST, ito sir ay PT, ito ay QT. Okay, so yung ating ST is just equals to the square root of PT square plus QT square. Okay, tatandaan nyo, no? So kapag 2 wattmeter method, our QT is just equals to the square root of 3 wattmeter reading 1 minus wattmeter reading, which is just equals to the square root of 3 negative 1710 minus 3210. Okay, our QT is just equals to, okay, solvein muna natin. Square root of 3 negative 1710 minus 3210. Okay, so lumabas, negative 8521 o 8522 volt ampere reactive. Okay, so PT naman natin is equals to wattmeter reading sum. Okay, so W1, okay, negative 1710 plus 3210. Okay, therefore, ang ating wattmeter reading naman, so plus naman to, $1,500. Okay, para makuha natin yung SD, it is just equals to the square root of 1,500 square plus, okay, so negative 8,522 square. Okay, our total apparent power, ST, is just equals to, okay, so 8653 volt ampere. Okay, so in getting the line current, our line current is just equals to ST, which is 8653, all over square root of 3 ng line voltage. Line voltage ko, 2 volt. Okay, so 20.82 ampere. Okay, so pinakamalapit, letters. Okay, so letter. Okay, so next. Okay, sige, kopya muna. Okay, so next problem is problem number 92. Okay, problem number 92. Okay, so problem number 92 sabi, an 8 by 11 sheet of metal is illuminated by a source 1.3 meter directly above. Okay, if the intensity of the lamp, okay, is equals to 200 candela, ano yung hinahanap na? Total luminous flux. Okay, total luminous flux ng source is just equal to, yung hinahanap, intensity is just flux per unit solid angle. Okay, but flux per unit solid angle is just 4 pi kapag ka buong sphere, no? Full sphere yung kinonsider. Okay, o yung buong luminous, o yung buong body. Okay, therefore our flux is just equals to intensity times 4. Yung magiging sagot natin, flux emitted by the source is just our intensity 200 times 4 pi. Okay, which is just equals to Okay? So approximately 2,510 lumen. Okay, so letter C. Okay, problem number 90. Okay, so next, 93. Okay, problem 93. So a step-up transformer. Okay, so in terms of turns ratio, turns ng primary to secondary is just equals to the voltage primary all over the secondary. Okay, so number of turns ng primary, 100. All over secondary, 400. Is just equals to the primary voltage which is 120 all over the secondary voltage. Okay, the secondary voltage therefore is 120 volts. Okay, so letter B. Okay, so letter B. Okay, so next is okay, problem number 120 tuloy. 120 times 4 pala yan, but 120. 480, sorry. Okay, so next problem. Problem number 90. Okay, problem number 94, ganun din, no? So, at maximum efficiency, our iron losses should be equal to the copper losses at that particular loading. Okay, sir, iron losses, 300. Okay, the full load copper loss, okay, so PCUFL is 600 watts. Okay, the percent load at which the transformer is expected to have the maximum efficiency is blank. Okay, so dito, okay, our PCUX is just equals to X squared PCUF. Okay, our PCUX is 300, which is just equals to X squared multiplied by the copper full load losses. Okay, X is equals to 0.707, which is equals to 70.71%. Kapag multiply nyo ng 100%. Okay, so letter. Okay, yan lang naman yung problem number 94. Okay, next problem is 95. Okay, question dito. Okay, so problem number 95. Okay, so in a cellular telephone system, group of cells is called cluster. Okay, so letter 1. Okay, so letter 1. Okay, so next is problem 96. Okay, problem number 96, at 300 candela lang is suspended, no? So ito yung tsura. Okay, at 300 candela lang, okay, is suspended 5 meter above and 2.5 from the edge. Okay, so with respect to the paper. Okay, so na hinahanap, illumination ng paper natin. Okay, so kapag may angle na yung ating light with respect dun sa area na iniilawan natin, okay, so Lambert's cosine line ang ginawa. Total illumination E is just equals to I cosine theta all over R squared. Okay, but our R is just equals to the square root of our X squared, which is 2.5. Ito yung R natin, ha? Plus 5 squared. Okay, so 5.59. Okay, so our cosine theta is just the adjacent side, which is 5, all over the hypotenuse, which is 5.15. Kaya pag kinumpute natin yung illumination E is the intensity, which is 300 candela. Cosine theta is just the ratio, no, nung 5 all over 5.59. R square, where R is 5.15. Okay, kaya ang lalabas sa sagot dito is 8.59 lux. Okay, so letter E. Yan yung solution natin for problem number 96. Okay, next is question number 97. Okay, question number 97. Okay, so meron daw tayong shunt motor. Okay, so sinabi niya 120 volts shunt motor. Okay, field resistance is 160 ohm. Okay, sabi niya the armature resistance is 1 ohm. Okay, so hanapin muna natin yung field current. Our field current is just the voltage ng field natin all over RF. Okay, sir, ito yung RF ko, no? So, but our VF, which is the field current, voltage I mean, is 120 volts, no? Equal lang siya sa source voltage natin or terminal voltage since connected sila in parallel. 120 divided by 160, which is just equals to 0.75 amp. Okay? So dito kasi ang tinatanong, sir, is actually our starting resistance to reduce the starting current to 30 amp. Okay? So una, saan natin ilalagay yung starting resistance? So ilagay natin yung starting resistance dito. Okay? So kapag nag-KVL kayo dito, okay, yung starting current natin dito is the line current. KVL, okay, total voltage is equals to IL multiplied by RST plus K IARE plus EB. Okay? IL, ito yon times yung dumaang resistance sa kanya, yung resistance niya, RST, plus IA multiplied by RAAB. Okay? So, para mahanap natin yung IA during starting is just equals to IL minus IF. Okay? KCL lang dito. Okay? So, starting current is 30 ampere minus the field current which is 0.72. Kaya yung ating starting armature current is 29.25 ampere. Okay? So, our terminal voltage, therefore, is just equals to IL. Okay? Where IL is 30 ampere. So, ibig sabihin, sir, wala tayong pakialam dito sa starting current, sa full load current. Kasi nga, ang tinitingnan natin dito, kailangan nating solve is yung starting series resistance during starting. Okay? So, 30 at starting to, the starting IL is 30. RST, so terminal voltage, I mean, so 120 volts. IL is 30. Our starting resistance is unknown. Okay, so plus IA. Sir, ang IA ko is IL minus IF, which is 29.25 ampere. RA ko, sir, is 1 plus back EMF ko. Okay, back EMF is 0. Okay, at starting, the back EMF is 0. Okay, therefore, pag sinolve natin yan, the starting resistance is equals to 3.03 ohm, which is approximately 3.0. Okay, so ang tamang sagot, letter. Okay, so letter C. So letter C for problem number 97. Okay, so next problem is 98. Okay, so problem number 98. Okay, so sabi, a 100 kilowatt, 3-phase delta connected motor works on a supply of 3.3 kilovolt. Okay, so the motor efficiency is 92% and the power factor is 90. The line current drawn by the motor is blank. Okay, the line current dito pa rin manggagaling. Okay, therefore, the total apparent power, the line current, I mean, is just equals to ST all over square root of 3V. Okay, sir, meron na ba tayong ST? Wala pa. Okay, our ST is just equals to the power total all over the efficiency. Power factor. Okay, but our power total, which is the input power, is just the output power divided by the efficiency. Okay, kaya pag sinolve natin yung power total muna, sir, output power is 100 kilowatt divided by our efficiency, which is 0.92. Okay, so pag sinolve natin yan, ang power total natin, okay, so 108.7 kilowatts. Okay, so in terms of ST natin, ST is just equals to power total, which is 108.7 divided by power factor, which is 0.2. Total apparent power. Okay, so 120.7 8. No? KBR. KBE. Okay, IL therefore is 120 times 10 raised to 8. Okay, raised to 8 tuloy. Raised to 3. Volt ampere all over square root of 3 ng line voltage natin. Line voltage is 3.3 volts. Kilovolts. Our IL is approximately 21 ampere. Okay, so letter. Okay, so letter. Okay, so yan yung problem number 98 natin. Okay, so next problem is 99. Okay, problem number 99 in GSM, SIM stands for, so letters. Okay, so subscriber identity mode. Okay, so letter. Okay, so next problem is 100. Okay, problem number 100. Okay, so lumabas nung April 2017. Wala, dito lumabas nung actual, no? Hindi ano to? Palito. Okay, so tanggalin ko lang muna. Stop share. Okay, so problem number 100. Okay, so a three-phase 440 volts induction motor has 4% slip. The frequency of the rotor would be blank. Okay, so in terms of the rotor frequency, it is actually equal to rotor frequency slip multiplied by the supply frequency. Okay, 4% which is 0.04 times our supply frequency which is 50. So tamang sagot 2 Hz. Okay, so letter. Okay, so yan yung problem number 100 na. Okay, so letter. Okay, sige no. So break time muna. Okay, then later. Okay, so si Sir Ergelius naman. Okay, so SSIT kung hindi ako nagkakamali yung next subject. Okay, so sige, break muna, break.